we have given diagram, and first we have to give another name for plane A. This is our plane A. First, what is plane? Plane has two dimensions. It is represented by a shape that looks like a wall or a floor, but it extends without end. Through any 3 points not on the same line, there is exactly one plane. We can use 3 points that are not on the same line to name a plane. So in our example, our plane A, we can name by, for example, E, F, I, because these 3 points are not in the same line. So the solution for A will be, first we can write E, F, I, this is name for our plane A, or we can write E, H, I, because these 3 points are not in the same line. Next, we have to give 2 other names for GF. We can use any 2 points on line to name it. In this example, our line GF can be named FG, we can use above arrows, or this is our line O. We have lowercase o. Next, we have to name a point that is not coplanar with E, H, and I. What is mean coplanar first? Coplanar points are points that lie in the same plane. So in this diagram, only point G is not in the same plane. So the answer will be point G. So next, we have to name 3 points that are collinear, then name a 4th point that is not collinear with these 3 points. So first, what it means collinear? Collinear points are points that lie on the same line. Points which are on the same line are E, F, and H. So we have and now we have to name the 4th point that is not collinear with these 3 points. So this point is I. This point is not collinear with E, F, H, because E, F, H lie on the same line and I not. So the answer will be I, point I. This is my solution. We have given diagram. On this diagram we have 2 lines and they are crossed in point B. First, we have to give another name for ray DB. DB ray. First, what is the ray? The ray DB consists of the endpoints D and O points on line DB that lay on the same side of DB. So this is our ray DB. The endpoint is D. We have to give another name because on this right side of D we have point E, so another name for ray DB will be DE. So we have solution for question A. It will be ray DE. This is another name for ray DB, DE. The endpoint is D. The same. Next we have to give name to pair of opposite rays. First, what is opposite rays? Let's choose first line L. When we have point between 2 points, between D and E, we have point B. Then the ray BD and BE are opposite rays. So the answer to question B will be BD ray and BE. And on the line K, we have between A and C point B. So the ray BA is opposite to BC. So we have BA ray is opposite to BC. Next, we have question, what is another name for segment DE? DE, this is our segment. First, what is the segment? Segment DE consists of the endpoints of D and E and all points on line DE that are between D and E. So another name for segment DE will be ED. We can write. Now we have to name all rays with endpoint B. We have point B. Let me remind you one more time. When we have ray, for example, endpoint will be A and we have B. So the ray AB consists of the endpoint A and all points on the line AB that lie on the same side of A as B. So we have to name all rays with endpoint B. So it will be BC, BA, BD, and BE. The endpoint is B. So this is my solution. We have given diagram, and first we have to name 3 planes that intersect at point B. Intersect, it means that they have one point in common. We see that plane GBC, this plane, and GBA, so I can write this, and on the bottom we have plane CBA. These 3 planes intersect at point B. So the answer for A will be plane GBC. Next, like I said, GBA. And on the bottom we have CBA plane. Next, we have to name the intersection of line BC. Let's find BC. BC, this is our line BC. And we have HC. We see that line HC and BC intersect in point C. So intersection of these two lines is point C. So this is our answer for B, question B. This is point C. Next, we have to name the intersection of plane FGH. Let's find this plane FGH. So this is on the top. Let's use different color. FGH. So this is our plane FGH and plane GHC. So intersection of these two plane is line HG. So the answer for C will be line HG. Or we can write GH. Next, we have to name the intersection of plane ABC. ABC is at the bottom. This is our ABC. And plane EHC. EHC is on the back. This is our EHC plane. So intersection of this plane on the back and on the bottom is line DC. So the answer for D is line DC, or we can write this is the same CD. Next, we have questions. Are points A, B, and C collinear? First, what it means collinear? Collinear points are points that lie on the same line. We see that points A, B, C are not lying on the same line, so they are not collinear. So we can write points A, B, and C are not collinear. And last question, are they coplanar? Coplanar points are points that lie in the same plane. We see that points A, B, and C lie on the same plane. This is this plane. So they are coplanar. We can write that points A, B, and C are coplanar. This is my solution. We have given equation of a line y equals x minus 5 and a point B which have coordinates 6 and 1, and we have to check if this point laying on the line y equals x minus 5. We use substitution method. We know that first coordinate is x and the second is y. It means we have to substitute in our equation x by 6 and y by 1. Let me write as that. X is equal 6 and y is equal 1. So let me copy our equation. Y equals x minus 5. Y is 1. So on the left side we have 1. And on the right side we have x equals 6. So 6 minus 5. 1 is equal 6 minus 5 is 1. Left side is equal to the right side. So it means that our point is on the line y equals x minus 5. This is my solution. We have given equation of a line and a point. We have to check if this point is on the line y equals negative 3x plus 6. We use substitution method. We know that first coordinate is our x and the second is y. So we can write that x is equal 2 and y is equal 0. So now we have to come back to our equation. We have y is equal negative 3x plus 6. So now we have to substitute x by 2 and y by 0. So we have on the left side 0 is equal negative 3 times 2 plus 6. So 0 is equal negative 3 times 2 is negative 6 plus 6. So we have 0 is equal negative 6 plus 6 is 0. Both sides are equal. So it means that our point B is on the line y equals negative 3x plus 6. This is my solution. We have given point and we have equation of a line, and we have to check if this point is on this line. So we know that first coordinate of point B is our x and the second is y. So we can write that x is equal negative 1 and y is equal 3. We will use substitution method. So it means we have to replace x by negative 1 and y by 3. If this point is on this line, it means that the left side will be equal to the right side when we substitute x by negative 1 and y by 3. So let's see what will be. Y is, let me copy first, y is equal 6x minus 2. So we have on the left side y equals 3, so we will substitute y by 3. So this is equal 6 times negative 1 because x is negative 1. And we have to copy negative 2. So we have on the left side 3, and on the right we have 6 times negative 1 is negative 6, and we have negative 2. So 3 is equal negative 6 minus 2 is negative 8. Left side is different than the right side. It means that our point B is not on this line. So we can write that point B is not on the line y equals 6x minus 2. This is my solution. We have given equation of a line and a point and we have to check if this point is on the line y equals negative 1/2 x plus 3. We know that first coordinate of point B is x and the second is y. So we can write that x is equal negative 2 and y is equal 4. Now we use substitution method to check if this point is on this line. So we have to copy equation of our line y is equal negative 1/2 x plus 3. Next we will substitute x by negative 2 and y by 4. So we have 4 is equal negative 1/2 times negative 2, we will put in parentheses, plus 3. So we have 4 is equal, negative times negative give me positive. So, and because we have multiplication, so we can reduce 2 and 2, so it will be 1, positive 1, like I said, because negative times negative give me positive, and we have plus 3. So on the left side we have 4, and on the right 1 plus 3 is 4. Left side is equal right side. It means that point B is on the line y equals negative 1/2 x plus 3. We can write point B is on the line. This is my solution. We have given inequality x greater than or equal 5, and we have to draw the graph of inequality on the number line. So let's draw x line, number line, and now we have to choose unit because we have 5. So let's put 0 and small unit 1, 2, 3, 4, 5 we have. Because we have symbol greater than or equals, it means that 5 belongs to solution. So we have this point, and x is greater. Greater value we have on the right side of 5. So this is going to positive infinity from 5. So we see that the graph for this inequality is array. Endpoint is 5 and is going to positive infinity. This is my solution. We have given inequality and we have to draw a graph for this inequality. We need number line x, because we have x is less than or equals negative 2. This number line going from negative infinity to positive infinity, of course. We need to choose the unit. We have 0, negative 1, negative 2. And next, because we have here x is less than or equal, so negative 2 belongs to our solution, and we have to find value x is less than negative 2. Less, it means we will have to go to the left side from negative 2. So we see that the graph is array. This is my solution. We have given inequality absolute value of x minus 1 is less than or equals 0. Let's first write definition of absolute value. When we have absolute value of a, this is equal a when a is greater than or equals 0, and negative a when a is less than 0. In our example, a is equal x minus 1. So we can rewrite our absolute value. We have x minus 1 is equal, from definition of absolute value, we will have two cases, will be x minus 1. We see we have to get rid of absolute value bars, and we have to copy whatever is between these bars. When whatever is between these bars, it means x minus 1 is greater than or equals 0, and we have to put negative sign before x minus 1 when x minus 1 is less than 0. So now we can solve these inequalities and rewrite second case because we have negative sign. So this is equal. First, we have to copy case x minus 1 will be the same. For x, we will move negative 1 to the right side, so will be x is greater than or equals 1. And we have negative sign before x minus 1, so we have to change the sign, so it will be negative x. Negative and negative give me positive 1. And this is for x is less than 1. So now we can come back to our inequality. This is our first case and this is our second case. First, when x is greater than or equals 1, we have to copy whatever is between absolute value bars. We have x minus 1 and we have inequality symbol less than or equals 0. Now we have to solve this inequality. We will move negative 1 to the right side, so we have x is less than or equals 1. So the domain for this case is x is greater than or equals 1, and we have x is less than or equals 1. So we can draw number line now. Number line x. We have to choose 0 and unit 1 we have. First we have inequality x is greater than or equals 1. Equals, it means that 1 belongs to our solutions. Greater, so it's going to positive infinity, and this was our domain, and we have inequality x is less than or equals 1. So 1 belongs to, and this is going to, let's use different color, left side because x is less. So the common point is 1. So the solution for first case is point. So let's see what will be in the second case. For x less than 1, when we take absolute value bars, we have to put expression negative x plus 1. And we have to copy inequality symbol less than or equals 0. Now we have to solve this inequality. We have negative x. We will move positive 1 to the right side, so it will be less than or equals negative 1. We have to change the sign. And now we divide both sides by negative 1. And we know when we have inequality and we divide both sides by negative number, we have to change the direction of inequality. So it will be x is greater than or equals 1. So now we will draw the graph. We have number line x and we have our domain x is less than 1. So we have 0, 1. Because we have x is less than 1, so we will draw the circle and we are going to negative infinity because we have x is less. Value less we have on the left side of 1. And our inequality is now x is greater than or equals 1. So we will use different color. 1 belongs to this inequality. We can draw something like this. And we're going to positive infinity because x is greater than 1. And we see that our solution doesn't have common point with our domain. So in the second case, we don't have solution. So the solution for our inequality, which we have at the beginning, will be only the solution from the first case. The solution is a point. So this is my solution. We have to graph in the inequality on the number line. So let's draw first number line. X is going from negative infinity to positive infinity. Next we have to choose a unit. We have 0, 1, and we have to find negative 4 and 3. Negative 4 will be on the left side of 0, so we have negative 1, negative 2, negative 3, negative 4, and we have to find 3, 2, 3. Next, because we have here x is less than or equals, so it means 3 belongs to our solution, so we will draw this and this point, and we have negative x is greater than or equals negative 4. So it means negative 4 belongs to our solution too. So now we have x is less than 3. So we are going to left side because x is less than 3 on the left side of 3. So this is first inequality, and next x must be greater than negative 4. So we have value greater than negative 4 on the right side of negative 4. So we are going to right side because we have here that x must be less than or equals 3 and x must be greater than negative 4. So we have to put together these two inequalities. We can rewrite this that x must be less than or equals 3 and x must be greater than or equals negative 4. So the solution to our inequality will be from negative 4 to 3 because x must be less than 3 and must be greater than negative 4. So the solution is between negative 4 and 3. These all numbers between negative 4 and 3, and of course 3 and negative 4 belongs to our solution because we have symbol x is less than or equals and x is greater than or equals. So negative 4 and 3 belongs to our solution. And we see that we got segment. So the solution for this inequality is a segment. So this is my solution. We have given here two inequalities. X is greater than or equals 7 or x is less than or equals negative 7. We have to graph these two inequalities on a number line. So let's draw number line. X is going from negative infinity to positive infinity. We need unit 0, 1, let's put, and we have 7 and negative 7. So 1, 2, 3, 4, 5, 6, 7 we have. and we need negative 7. Negative 1, 2, 3, 4, 5, 6, 7. Negative 7 is on the left side of 0. And next we have here inequality. First inequality is x is greater than or equals 7. It means 7 belongs to solution. Greater value. So we are going to the right side of 7. So we see that we get array for the first inequality, and for the second, because we have or, x is less than or equals negative 7. It means negative 7 belongs to solution, and value less than negative 7 we have on the left side of negative 7. So we are going to negative infinity. We see that we get another ray. So the solution for these inequalities are 2 rays. So this is my solution. We have to graph inequality on a number line. So let's draw first number line. Because we have x is greater than or equals negative 4, or x is less than or equals 1, so our number line will be x. We have to choose the unit 0, 1. We need negative 5 and 1, so we have negative 1, 2, 3, 4, 5. Next, because we have here x is greater than or equals, so negative 5 belongs to our solution, and x is less than or equals 1, so 1 belongs to our solution. First inequality is x is greater than or equals negative 5. Value greater than negative 5 we have on the right side of negative 5. So we are going to positive infinity. And the second inequality, because we have or, so we have to put together these two inequalities. We have or x is less than or equals 1. So value less of 1 we have on the left side of 1. So we are going to negative infinity. Because we have x is greater than or equals negative 5, or x is less than or equals 1, so the solution will be from this first inequality and from the second inequality. So we have to put this solution together, and we see that we got a line. We are going from negative infinity to positive infinity, so the solution is a line. This is my solution. We have given diagram, and first we have to name two pairs of opposite rays. To find pair of opposite rays, we have to find line which has 3 points. The line KL has 3 points, K, P, L. So first pair of opposite rays will be PK and PL. So the solution for A will be PK ray and PL. And let's find another line which has 3 points. Will be QO line. Between Q and O we have P, so we can have another pair of opposite rays. Will be PQ and PO has opposite rays. So we have PQ and PO. So this is our solution. Next we have to name the intersection of plane K, L, M this is our plane, and we have line OQ. This line intersects our plane at point P. So the solution will be point P. So solution is point P. Next, we have to name 3 points that are collinear and then give a name for the line that contains the points. First, what it means collinear. Collinear points are points that lie on the same line. So we have to find 3 points that lie on the same line. So this is K, P, L. These 3 points lay on the same line. So solution for C will be point K, P, and L. They are collinear because they are lying on the same line. Next, we have to give the name this line. So the name for this line is, we can write KL, or another name for this line can be LK or KP, PK, PL, or LP. This is line KL. We can write only one example. Another 3 points that are collinear are O, P, and Q. They are on the one line. So we can write that O, P, and Q lay on the same line, and the name for this line we can write OP or OQ or PQ or QP, or so it doesn't matter. We can write like, we have many names for this line. We can use O, line OQ. And next question, are points K, M, and N coplanar? Yes, because they lay on the same plane, so they are coplanar points. So the answer for D is yes. And the last question, name a line that intersects plane KPN at more than one point. So our plane KPN intersects 3 lines. KM we see, and MP and KP. So the answer for E is line KM KP and line MP. So this is my solution. We have given segment AC. Point B is between A and C. We need to find the distance between A and C. We know that distance between A and B is 4, and distance between B and C is 7. So we can write equation that AC is equal AB plus BC. because we know distance between A and BC, so we can substitute these two values. So we have AC is equal 4 plus 7. So we have that AC is equal 4 plus 7 is 11. So the distance between A and C, or in other words, the length of segment AC is equal 11. This is my solution. We have to find length of segment LM. We have given segment KM that the length of KM is 42 and the length of KL is 8. So we can write equation that KM segment is equal KL, because L is between this K and M, plus LM. Now we can substitute segment KL by 8 and KM by 42. So we have that 42 is equal KL is 8, and we have LM. We don't know the length of LM. So now to find LM, we will move 8 to the left side, so it will be 42 minus 8. We have to change the sign. We have positive 8, so it will be now negative, is equal LM. So 42 minus 8 is equal 34. This is LM. So our segment LM has length 34. This is my solution. We have given segment DF. We know that the length of DF is 45, the length of EF is 15. We need to find distance between D and E. So let's first write our equation that DF, our segment DF, is equal DE plus EF. The distance of DF is equal to sum of two segments, DE, EF. And now we can substitute DF by 45. This is equal, DE is our unknown, so we just copy DE. And we have EF is 15, so we have plus 15. Now we will move 15 to the left side, so we have 45 minus 15 is equal DE. So 45 minus 15 is 30. This is our DE. We can rewrite our answer. DE is equal 30. The length of DE is 30. We have given segment XZ. We have that distance between points X and Z is 6a, and between Y, Z is 2. We need to find the distance between X and Y. So let's start from the beginning. We have segment XZ. XZ is equal XY plus YZ. Our XZ is 6a. XY is our unknown, and we have YZ is 2. So XY we have to copy, we have plus 2. Next, I will move 2 to the left side, so it will be 6a minus 2. We we have to change the sign. We have positive on the right side, so when we move to the left side will be negative 2 is equal xy. We can rewrite on the left side, we will put xy is equal 6a minus 2. What else we can do? We can factorize 2. So we will have xy is equal 2, and in parentheses we will have 3a minus 1. Or we can left like this. This is my solution. We have to plot the given points in the coordinate plane first, and next we have to determine wherever the line segments named are congruent. First, let's draw xy plane. Because we have only positive coordinates here, so we don't need negative values. So let's put something like this. This is our x and this is our y axis, and next we need to choose the unit because we have 7, so let's put not too big. This is our 1. First point is 1, 3. First coordinate is always x. The second is our y. So we have x 1 and y is 3. So 1, 2, 3 we have. So our point K is here. Has coordinates 1, 3. Next, we have point L, 5, 3. So first coordinate is x, second is y. X is 5, so we have 1, 2, 3, 4, 5. And y is 3 again. This is our 3. So let's find our L point approximately here. This is our L, 5, 3. Next, we have point M, 2, 3. First coordinate is x and the second is y. X is 2 and y is 3 again. So we have 2 and 3. So this is our M point 2, 3. Next we have N is 2, 7. 2 is our x and y is 7. So we have 3, 4, 5, 6, 7. And x was 2. So this is approximately our point N, 2, 7. Next, we have to check if segment KL, so let's draw the segment KL, is congruent with segment MN. This is our MN segment. So let's find the length of first segment KL. KL is equal, KL, the segment is horizontal. So to find the length of horizontal segment, we need to find the absolute value of the difference of the x coordinates of the endpoints. So the endpoint is, first x coordinate is 1, and for L, x coordinate is 5, 1 and 5. So we have to find absolute value of the difference of the x coordinates of the endpoints. So we have 5 minus 1. So this is equal absolute value of 4. So this is 4. Next, to find the length of MN, we see that segment MN is vertical. So to find the length of a vertical segment, we need to find absolute value of the difference of the y coordinates of the endpoints, because first coordinates is the same, 2 and 2. So we have to find the difference of the y coordinates only. So we have 7 and 3. Absolute value of 7 minus 3. So this is equal absolute value of 4. So this is equal 4. We got that the length of segment KL is 4 and the length of segment MN is 4. Because we have the same length for both segments, it means that these segments are congruent. So we can write that KL segment is congruent to MN segment. This is my solution. First, we have to plot the given point in the coordinate plane, and next we have to check if segment RS and TW are congruent. So let's draw XY plane first. We have horizontal line is X and vertical Y. We need to choose the unit. Let's see our R point first. First coordinate is always X and the second is Y. So we have -7 for X, -1, 2, 3, 4, 5, 6, 7. And Y is -6. So we will have 1, 2, 3, 4, 5, 6. So our R point will be approximately here. -7, -6 coordinates. And next we have S. First coordinate is X, second is Y always. So X is -7 again, and we have 4. Y, 1, 2, 3, 4. So this is approximately here. This is our S, -7, 4. Next we have point -2, -3. So -1, -2, -3, so 1, 2, 3. This is our T, -2, -3. And next we have -12, -3. So we have X is -12 and Y is -3. We have X -7, 8, 9, 10, 11, -12 will be approximately here, and we have Y -3. So this is our W, -12, -3. So now we have to check if segment RS segment and points S and R, and we have segment TW and points T and W. We have to check if these segments are congruent. It means we have to check if they have the same length. So let's first find the length of RS segment. RS is equal, when we have vertical segment, we see that first coordinates are the same, only the y coordinates are different. So we have to find the absolute value of the difference of y coordinates of the endpoints. So we have absolute value of 4 minus, and y is for r equals -6. So we will put -6 in parentheses. So this is equal absolute value of negative and negative we have in absolute value bar, so give me positive. So we have 4 plus 6 is 10. Absolute value of 10 is equal 10. Now we have to find the length of segment TW, because TW is horizontal segment. So to find the length of horizontal segment, we need to find absolute value of difference of the x coordinates of the endpoints, because y coordinates are the same. So we have absolute value of first coordinate is of t is -2 minus, and in parentheses we have -12. So this is equal absolute value of -2. Negative and negative give me positive, so will be plus 12. So this is equal absolute value of -2 plus 12 is 10. Absolute value of 10 is 10. We got that the length of segment RC and TW is the same, 10. It means that segment RS is congruent to segment TW, because the length of these two segments are the same. This is my solution. We have given points, and first we have to plot the given points in the coordinate plane, and next we have to check if the given segments DE and FG are congruent. So let's draw first XY plane. Because we have here points -100, 300, 400, 200, so let's choose the unit 100. And we know that first coordinate is x and the second is y. We have -100x, so it will be on the left side of 0. So this is -100. And for y we have 300. 1, 2, 3. So our point will be approximately here. This is our D. E is -100, 0. So this is our E, -100, 0. And we have F, 400. So will be 200, 3, 400. Let's put here. And for y we have 200, so 100, 200. So our point F is approximately here, and we have coordinates 400, 200. G has coordinates 100, 200. So x is 100 and y is 200. So this is approximately here. This is our G. We have to check if segment DE and FG are congruent. To check if these two segments are congruent, we need to find the length of DE and FG. So DE segment, this is our DE, and GF or FG, doesn't matter how we name the segment. The distance between these two endpoints, G and F, is the same. So let's find first DE. This is equal because segment DE is vertical. To find the length of vertical segment, we need to find the absolute value of the difference of the y-coordinates of the endpoints, because a-coordinate, x-coordinates are the same, -100. So let me put that D has -100, 300y. So we have to take absolute value of the difference of the y-coordinates, because DE is the same like ED. So we can put that we have absolute value of 300 minus, and y-coordinate for E is 0. So we have 300 minus 0. So this is equal, absolute value of 300 is 300. And we have to find length of segment FG. FG or GF is still the same length. So let me put FG, because segment FG is horizontal, so the y-coordinates is the same, 200. So we need to find the absolute value of the x-coordinates only, because y is the same. So we have 400 minus 100. So this is equal absolute value of 300. So this is 300. We got that the length of segment DE and FG or GF is still the same segment, is 300. It means that the segment DE is congruent to segment FG. This is my solution. We have given points A, B, C, D, and E, and these points are collinear. It means they are laid on the same line. What else we know? We know that AE, the length of AE is 74. So this is 74. And we know that CE, well, length of CE is 30. What else we know? That BC is equal to CD and DE. So the length of BC is the same like CD and DE. We have to find first DE, because we know the length of CE and CD is the same like DE, so we can write equation that first A, we have that CE, length of CE is equal CD plus DE, because CD is the same like DE. Can write because CD is equal DE. So we can rewrite our equation that CE is equal DE plus DE, because CD is DE. So let me write that this is DE plus DE. So we can rewrite our equation that CE is equal to DE. We know that CE is equal 30. So we can replace CE by 30 is equal to DE. We have multiplication here, so we can divide both sides by 2. So we will have 2 and 2 we can reduce, and we have that DE is equal 30 divided by 2 is 15. So we have the length of DE. Next, we have to find AB. AB. Because we have that BC is the same like CD, DE, and we found that DE is 15. So we have that this length between B and C point is 15. So now we have to find AB. First we have to write equation. We know this whole part, the length of this whole part. We know length of AE. We have to find AB. So let's write equation that we have AE is equal AB plus BC plus, we can write CE. So we have AB plus BC plus CE. So now we can substitute AE by 74. So we have 74 is equal, AB is our unknown. We have plus BC, we have that this is 15, and CE is 30. So we have 74 is equal AB plus 15 plus 30 is 45. Now to find AB, we will move 45 to the left side. So we have 74 minus 45 is equal AB. When we move positive number to the other side, we have to check the sign. So that's why we have negative 45 now. And now 74 minus 45 is equal 29. So this is our AB. We can rewrite that AB is equal 29. Next, we have to find AC. So let's put this here. We have to find AC. AC is AB plus BC. We found that AB distance between A and B is 29. So we can write that AC is equal AB plus BC. So our AC will be AB, the length of AB is 29. We have plus BC, length of BC is 15. So we have that AC is equal 29 plus 15 is 44. So we found AC, length of AC. Now we need to find only length of BD. So question D, BD is equal BC, the length of BC plus length of CD. So we have BC plus CD. So our BD is equal, BC we have, but this is 15. And we know that CD is equal to BC. We have given at the beginning that BC is the same like CD and DE. So because we have BC, so now we can substitute that CD is 15. So our BD, the length of BD is equal 30. This is my solution. We have given that 4 towns lay along a straight highway in this order: town K, town L, town M, and town N. So we can draw the graph first because these 4 towns lay on the straight highway, and we have order that first is town K, next is L, M, and at the end we have town N. So this is our highway, and we have town K, L, M, and N. Now, next we have given that distance from town M to town N. The distance from town M to town N is 20 miles. Next, we have given that town K, that the distance from town K to town L is 5 times the distance from town L to town M. So if we put that the distance from town L to town M is our, can put L, X, this is our X. We had that the distance from town K to L is 5 times the distance from L to M, because this distance, I put that this is our X, so the distance from K town to L town will be 5 times X. Because we have given that the distance from town K to town L is 5 times the distance from town L to town M. Next, we have given that the distance from town K to town N, town K to town N, the distance from town K to N is 2 times the distance from town K to L. And we put that the distance from towns K to L is 5x. So now we have to put in parentheses that we have 2 times 5x, because we have 2 times the distance from town K to town L. And what we have to find? We have to find first the distance from town K to town L. So first, because we have here only one unknown x, first we can write equation that distance from K to N is equal the sum of distance from K to L plus L to M and M to N. So we have K L plus LM plus distance from M to N. So now we can substitute Kn, distance from Kn is 2 times 5x. This is equal KL, distance from KL is 5x. Plus we have LM, we have x. And we have plus MN, distance from tau M to N is 20 miles. So we can write 20 now. So now we have equation and we have only one unknown. So first we will do multiplication. 2 times 5x is 10x. This is equal 5x plus x is 6x, and we have plus 20. Now I will move unknowns to one side, so it will be 10x minus 6x is equal 20. 10x minus 6x is 4x. So this is equal 20. Now we will divide both sides by 4 because we have multiplication and we need to get x. So we have that x is equal 20 divided by 4 is 5. We have our unknown. X is equal 5. So now it will be very easy to find the distance from town K to town L. So let's put our A question. We need to find the distance from town K to L. So this is equal 5x. So now we have to substitute x by 5. So this is equal 5 times 5 because we found that x is equals 5. So this is equal 25. And we have to add the units. We have given mile. This is our solution for question A. Next, we have to find the distance from town K to M. K to M is equal to sum of distance from K to L plus L M. So this is equal distance from K to L. We found that this is 25 miles. And distance from L to M is x. And x, we found that this is 5. So we have plus 5. Of course, mile. So this is equal 30 miles. And next, we need to find the distance from town K to town N. So this is equal K to N is equal 2 times 5x. X is 5, so we have 2 times 5 times 5 is 25. So this is equal 50, and of course we need to add miles. So next we need to find distance from town L to town N. D. From town L to town M. From L to M is x. We found that x is equal 5. So let me write that this is x and this is equal 5. We found. So we need to add the units. So this is my solution to this problem. In the diagram, we have given that EF, segment EF, is congruent to segment FG. It means that the length of segment EF is equal to length of segment FG because they are congruent. This symbol means that segment EF is congruent to segment FG. It means that the length of segment EF is equal to the length of segment FG. What else we have? That EG, so let me use different color, segment EG is congruent to segment GH. So it means that length of EG is equal to length of GH. And we have given that length of segment EH is 24. We have to find the length of all the segments in the diagram. So first we have given that EH is equal 24. And we have given that length of EG segment and GH are equal. So we can write equation that EH is equal to sum of lengths EG plus GH. Because, like I said, EG is equal GH, so we can rewrite that EH is equal GH plus GH. I just substitute EG by GH because they are equal. So we have that EH is equal to GH. EH we have given that this is 24, so we have 24 is equal to 2 times GH. Now we can divide both sides by 2. So 2 will reduce, and we have that GH is equal 24 divided by 2 is equal 12. We have GH, it means that we have EG because length of GH is the same like length of EG. So we can write that EG is equal 12 too. Now we need to find EF and FG because we have given that EF and FG are congruent, like I said, so it means that the length of EF, we can write EF is equal FG. So, and we have that EG, length of EG is equal 12. So let's write equation that EG is equal sum of lengths EF plus EFG. So we have EF plus FG. So our EG is equal, because EF is equal FG, so we can substitute EF by FG, and we have plus FG. So our EG is equal 2 times FG. EG is equal 12. So we have 12 is equal 2 times FG. So now we can divide both sides by 2. 2 and 2 we can reduce, and we have that FG is equal 12 divided by 2 is 6. We have FG because FG is equal EF. So we can write that EF is equal 6. So we found that EF is equal 6, FG is the same, and we have GH. So we solve our problem. We have given that point B is between A and C on segment AC. We have to use the given information to find the length of AB and BC. So let's draw first the graph. We have given segment AC. Point B is between A and C, so this is our B. We have given that AB is 2x minus 6, and we have that BC is 5x minus 4. What else we have given? That length of AC is 25. So we can write equation that AC is equal AB, the length of AB, plus length of BC. So we have AB plus BC. Now we can substitute AC by 25, AB by 2x minus 6, and we have given that BC is 5x minus 4, so we have plus 5x minus 4. Now we can combine the like terms, so we will have 25 is equal to x plus 5x is 7x, negative 6 and negative 4, so this is negative 10. Now we will move negative 10 to the left side, so will be positive 10. 25 plus 10 is equal 7x. 25 plus 10 is equal 35. This is equal 7x because we have multiplication on the right side, so we will divide both sides by 7. 7 and 7 we can reduce, and we have that x is equal 35 divided by 7 is 5. When we have x, now we can calculate length of AB and BC. So we had that AB is equal 2x minus 6. So this is equal x. We have that this is 5, so we have 2 times 5 minus 6. So this is equal 2 times 5 is 10 minus 6 is 4. And BC, length of BC is equal 5x minus 4. X we will substitute by 5. So we have 5 times 5 minus 4. So this is equal 25, because 5 times 5 is 25, minus 4 is 21. So we found the length of AB and BC. This is my solution. We have given that point B is between A and C on segment AC. So let's draw the graph first. We have segment AC, point B is between AC, and we have given that AB, length of AB is 4x plus 5. The length of BC is x minus 3, and we have given that length of AC is 42. We can write equation that AC is equal AB plus BC. So now you can substitute AC by 42. AB is 4x plus 5. And we have given that BC is x minus 3. So now we can combine the like terms, and we have 42 is equal 4x plus x is 5x. 5 minus 3 is 2, so we have plus 2. Now I will move 2 to the left side because we have positive 2, so it will be 42 minus 2 is equal 5x. 42 minus 2 is 4 is equal 5x. Now because we have multiplication here, so I will divide by 5 both sides because we need to find x. 5 and 5 we can reduce, so we have that x is equal 4 divided by 5 is 8. We have x, so we can calculate the distance between A and B and C, because AB is equal 4x plus 5. Now we can substitute x by 8, so we have 4 times 8 plus 5, so this is equal 4 times 8 is 32 plus 5 is 37, and we need to find BC. So BC is x minus 3, so this is equal x is 8 minus 3, so this is equal 5. So this is my solution. We have given that line K bisects the segment. It means that segment AB now is congruent to segment BC, because line K bisects the segment. It means divide this segment AC to 2 segments, and they had the same length. So we can write now that segment IB is congruent to segment BC. So it means that length of AB is equal to length of BC. And we need to find the length of AC if length of AB is equal 3/4 inch. We can write equation that AC is equal AB plus BC. What else? Because the length of AB is equal to length of BC, so we can write that AC is equal, because we have given that the length of AB is equal 3/4, so we will substitute length of BC by AB, so we will have AB plus BC is equal AB. So we have now that AC is equal 2 times AB, because we have AB plus AB. And what else we have? That AB we have given is equal 3/4. So we can write that this is equal 2 times 3/4 inches. So this is equal, we can reduce 2 and 4 will be 2. So we have that length of AC is equal 3/2 inches. So we solved the problem. We have given that line K bisects the segment EG. It means that segment EF is congruent to segment FG. We can write that EF is congruent to FG. What it means? That length of EF is equal to length of FG. We have to find length of segment EG, and we have given that FG is equal 6 and 1/7 inches. So we can write equation first that length of segment EG is equal to sum of length of segment EF plus FG. Because we have given FG and we have given that EF is equal to FG, so we can rewrite our equation that EG is equal, instead of EF, I can write FG because they are equal. And we copy FG. So we have that EG is equal 2 times FG because we have FG plus FG. So we have 2 times FG. And we have given that FG is equal 6 and 1/7. So we can rewrite that we have 2 times 6 and 1/7 inch. So this is equal 12 and 2/7 inches. This is my solution. We found length of segment EG. We have given that line K bisects the segment. It means that our segment is divided to 2 equal segments. So we can write now that segment AB is congruent to segment BC. It means that the length of AB is equal to length of BC. So we have to find length of AB, and we have given that length of AC is 21 centimeters. We can write equation. We have segment AC, and this segment we can rewrite that this is equal to sum of these 2 segments. So we have length of AB plus BC. What else we know? We know that AB is equal BC. So we can substitute BC by AB. Why I substitute BC by AB? Because we have to find AB. So we don't need in this equation BC. So we have AC is equal AB, I copy, and this BC I substitute by AB. Because this line divides this segment to 2 equal segments. So we have now that AC is equal to AB. we have given that AC is equal 21. So I will substitute AC by 21. This is equal 2 times AB. Because I need to find AB, now I will divide both sides by 2. Because we have multiplication here, 2 and 2 we can reduce, and we have that AB is equal 21 divided by 2. So this is equal 10 and 1/2. And we have to add the units, centimeter. So this is my solution. We have given that the line K bisects the segment. It means that segment KM is divided to 2 segments and they are congruate. So we can write that segment KL is congruate to segment LM. It means that length of KL is equal LM, to length of LM. We have to find length of LM, and we have given that length of KM is 246 meters. So we can write equation because we have given segment KM, and this segment is divided to 2 segments. So we have KL plus LM. Now, because we have given that KL is equal LM, and we need to find LM, so I will substitute KL by LM to have LM only in this equation. So we have KM is equal LM because KL is equal LM. And we have to copy LM. So length of segment KM is equal 2 times LM. We have given KM, so we can substitute. This is 246 meters is equal 2 times LM. Because we have multiplication, so I will divide both sides now by 2. So 2 and 2 we can reduce, and we have that LM is equal, we have to divide 246 by 2, so this is 1, 2, 3, 123 meters. So this is my solution. We found length of LM. We have given that M is the midpoint of the segment. What it means? If M is the midpoint of AB, segment AB, it means that segment AM is congruate to segment MB. So it means that length of AM is equal to length of MB. We have given that AM is equal 5x minus 44, and we have given that length of MB is equal to 2x plus 16. We need to find length of AB. We can write that AB is equal AM plus MB. And what else we know? That AM is equal MB. So we can write equation, because AM is equal MB, we can substitute AM by 5x minus 44. This is equal, MB is 2x plus 16. So So we have equation and we have only one unknown x, so we can find x now. We will combine the like terms. I will move 2x to the left side, so it will be 5x minus 2x is equal 16. I will copy and I will move negative 44 to the right side, so it will be plus 44. 5x minus 2x is 3x is equal 16 plus 44 is 60. So now we divide both sides by 3, so we have x is equal 20. We have x. So now we can come back to our equation. We have to find AB. We have that AM is equal MB. So we can substitute AM by MB. So we will have MB and we have copy MB. So our length of AB is equal 2 times MB, because MB plus MB is 2 times MB. What else? MB is 2x plus 16, so we have 2 times 2x plus 16. So this is equal, our AB will be equal to, we can rewrite this, and x we can substitute by 20. So we have 2 times 20 plus 16. So this is equal, because we found that x is equal 20. So this is equal 2 times 20 is 40 plus 16 is 56. So we have 2 times 56, this is equal 112. So our segment, length of our segment AB is equal 112. This is my solution. We have given that M is the midpoint of a segment, and we have to find the length of XZ if XM is equal 6x minus 9 and MZ is 10x minus 49. Because we have given that M is the midpoint of segment XZ, it means that segment XM is congruent to segment MZ. It means that length of XM is equal to length of MZ. So because this length are equal, so we can write equation, because length of XM is 6x minus 9. We just substitute length of XM by 6x minus 9. This is equal length of MZ, so 10x minus 49. We have equation, one unknown, so we can find x. I will move 10x to the left side, so we have 6x minus 10x is equal, and we have negative 49, and because we have negative 9 on the left side, I will move to the right side, so it will be plus 9. 6x minus 10x is equal negative 4x. This is equal negative 49 plus 9, so this is negative 40. Now we will divide both sides by negative 4 to find x. Negative 4 we can reduce, and we have x is equal negative over negative give us positive. 4 divided by 4 is 10. So if we have x. Now we can find the length of xz. xz is equal to sum of length xm plus mz. Because xm is equal mz, so we can substitute xm by mz. So we have xz is equal mz, and we have to copy mz. So we have that xz is equal to times length of mz. So this is equal 2 times mz is equal 10x minus 49. So we have 10x minus 49. So this is equal 2 times x. We found that this is equal 10. So we have 10 times 10 minus 49. So this is equal 2 times 10 times 10 is 100 minus 49. So this is equal 2 times, in parentheses we will have 51. So this is equal 102. This is my solution. We found length of AZ. We have next example. Find the coordinates of the midpoint of a segment with the given endpoints. We have endpoints x and z. We can draw xy plane. And we will find our 2 points. We have x, 4, 7. X is always first coordinate because we have 2 points, so I will put this as x1, y1, x2, y2. And our first point is 4, 7. So let's choose small unit. 1, 2, 3, 4, 5, 6, 7. And of course, x is equal 4, so we have 1, 2, 3, 4, and y is 7. 1, 2, 3, 4, 5, 6, 7. So our point x is here, and we have point z. First x coordinate is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And we have negative 5. So negative 1, 2, 3, 4, 5. This is our z. We need to find midpoint, coordinates of a midpoint. It's approximately here is our M. We have formula for the midpoint. Let me remind you, when we have 2 points, we have to find the coordinates of the midpoint of a segment. We have formula M is equal average of the x coordinates and of the y coordinates of the endpoints. So we have xy plus x2 over 2, and the second coordinates is y1 plus y2 over 2. x1 is first coordinate of our x point, x2 is first coordinate of our z point, y1 is second coordinate of our x point, and y2 is second coordinate of our z point. So this is equal, x1 is 4, we have plus, x2 is negative 8 over 2, and second coordinate is y1 is 7 plus y2 is negative 5 over 2. So this is equal 4 plus negative 8 we have, so will be negative 4 over 2, and we have 7 plus negative 5, so this is 2 over 2. So this is equal, first coordinate is negative 4 over 2, so this is negative 2, and the second is 2 over 2, so this is 1. So this is our midpoint, so this is my solution. Find the coordinates of the midpoint of the segment with the given endpoints. So first we will draw xy plane. X-axis, y-axis, we need to choose unit because we have negative 8, so we can use small unit. This is 1. First point is negative 2, 2, so negative 1, negative 2, and y is 2. This is our P, and next we have to find R, so 3, negative 8, 2, 3, and negative 8, 1, 2, 3, 4, 5, 6, 7, 8, approximately here. So this is our point R. We can draw now our segment PR, and we need to find midpoint. Midpoint divide our segment to 2 equal parts. This is our midpoint. The coordinates of the midpoint of a segment are the average of the x coordinates and of the y coordinates of the endpoints. So if P has coordinates x1, y1, and R has coordinates x2, y2, the midpoint M of PR segment has coordinates x1 plus x2 over 2, and second coordinate is y1 plus y2 over 2. So this is equal, x1 is negative 2 plus r, x2 is 3 over 2, and we have y1 is 2, second coordinate of P point, plus second coordinate of R point is negative 8 over 2. So this is equal, we have M, negative 2 plus 3 is 1 over 2, and we have 2 plus negative 8, so this is negative 6 over 2. So our midpoint has coordinates 1/2 and negative 3. So this is approximately like on our graph. This is my solution. Find the coordinates of the endpoint B of segment AB if 8 point has coordinate 0, 3 and midpoint negative 7, 9. We can draw xy plane. X-axis, y-axis, we have point 0, 3, 1, 2, 3. So this is our A. We have midpoint negative 7, 9, 1, 2, 3, 4, 5, 6, 7, and 9, 3, 4, 5, 6, 7, 8, 9, approximately here. So this is our M. And because M is our midpoint, so our segment AB is going to be approximately here, our B point. We have A, we have M, we need to find B. Let's put that our point B has coordinates x, y. And now we can use midpoint formula. We know that coordinates of the midpoint of a segment are the averages of the x coordinates and of the y coordinates of the endpoints. So to find x, we have to solve equation because we have given A 0, 3, M is negative 7, 9, and B is xy, so we just use midpoint formula. So our x will be, we have to first add first coordinates of endpoints. So we have 0 for A and for B is x. So we have 0 plus x over 2 because we have average is equal, our midpoint first coordinates is negative 7. So we have to solve this equation. We have one unknown. 0 plus x is x over 2 is equal negative 7. Because we have fraction, we don't want this 2 in denominator. I will multiply both sides by 2. So we have 2 and 2 we can reduce, and we have x is equal negative 7 times 2 is negative 14. So we have x coordinate of B point. Now we have to find y. And again we will use midpoint formula. We know that the y coordinate of midpoint is sum of y coordinates of endpoints. So we have endpoint A and B. A has y coordinates is 3. We have plus, or y is the y coordinates of endpoint B. We have to divide by 2, and we had that y coordinates of M is 9. So now we can multiply both sides by 2 to reduce the denominator. 2 and 2 we cancel, and we have 3 plus y is equal 18. Now we will move 3 to right side, so we have y is equal 18 minus 3, so y is equal 15. We have x, we have y, so we can write that endpoint B has coordinates negative 14, 15. This is solution to this problem. We have to find the coordinates of the endpoint B of segment AB if A has coordinates negative 1, negative 5, and midpoint has coordinates 4, negative 3. So let's draw xy plane. This is our y-axis. This is x-axis. We have A negative 1, negative 5, 1, 2, 3, 4, 5, negative 5. So this is our A. And we have M for negative 3. 1, 2, 3, 4. And negative 3. 1, 2, 3. This is our midpoint. And let's put A has negative 1, negative 5, M 4, negative 3, and we need to find B, the second end point, because we have segment AB, so we have to pass our midpoint. This is our B. Let's put that B has coordinates x, y. We know formula for midpoint. The coordinates of the midpoint of the segment are the averages of the x coordinates and of the y coordinates of the endpoints. So we can write here that M has coordinates x. We have to add first coordinates of endpoints and divide by 2. So we have negative 1 plus x over 2, and the second coordinate of midpoint, we have to add the second coordinates of endpoints and divide by 2. So we have negative 5 plus y divide by 2. So now we have equation. We have to find x and y. To find x, we have to solve equation. Negative 1 plus x over 2 is equal. We have that first coordinates of midpoint is 4. So it is equal 4. And to find y, we have to solve equation. The second coordinate of M is negative 5 plus y over 2 is equal. We have given negative 3. So now let's solve first equation. We will multiply both sides by 2 to reduce the numerator. So 2 and 2 we can reduce, and we have that negative 1 plus x is equal 4 times 2 is 8. So x is equal negative 1, we will move to the right side, so it will be 8 plus 1. X is equal 9. And we need to find y. I will multiply both sides by 2 to reduce the numerator again. So 2 and 2 we can reduce, and we have negative 5 plus y is equal negative 3 times 2 is negative 6. So now I will move negative 5 to the right side. So we have y is equal negative 6 plus 5. We have to change the sign of negative 5. So y is equal negative 6 plus 5. So this is negative 1. We found x and y. So we have that B, point B, has coordinates 9, negative 1. This is my solution. What is approximate length of segment xy with endpoints x 4, negative 7 and y negative 2, 3? First we can draw xy plane. We have point x 4, 2, 3, 4, negative 7, 1, 2, 3, 4, 5, 6, 7. This is our unit 1, negative 1. It's 4. So our point is approximately here. This is our x 4, negative 7. And y is negative 2, 3. So this is negative 1, negative 2, and y is 3. So 1, 2, 3. This is our point y. We have to find the length of segment xy. So we will use formula. Let's first put that y has -2, 3 coordinates, and let's put that x has coordinates 4 is our x1, -7 is our y1, and the second endpoint has coordinates x2, y2. The formula for length of segment xy is equal square root of, we have x2 minus x1 square plus y2 minus y1 square. So this is equal. Now we have to substitute x2, x1, y2 and y1. We have square root of, in first parenthesis we have to take the difference of first coordinates. So we have x2 minus x1. So we have -2 minus 4, have to take to second power, plus, and in second parenthesis we have difference of y coordinates. We have y2 minus y1. So this is 3 minus, and we have -7, so we need to put to parentheses -7, everything to second power. So this is equal, we have square root of -2, -4, so this is -6 to second power, and we have plus negative, and negative give us positive, so we have 3 plus 7, so this is 10 to second power. So this is equal square root of 6 to second power is 36 plus 10 to second power is 100. So this is equal square root of 136. So this is equal approximately 11.66, of course, units. This is my solution. Find the length of a segment with a given endpoint E and midpoint M. Let's first draw the XY plane, because we have 18, so let's put positive part of X very long. Let's choose small unit 1, and first endpoint is E, 0, -2, -1, -2, so this is our endpoint E. We have midpoint 18, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 approximately here, and the second coordinate is 4, 1, 2, 3, 4. So our midpoint is approximately here, has coordinates M, 18, 4, and E has coordinates 0, -2. Our second endpoint will be, let's put, will be F. It will be far away. I don't have place. Let's put that this is our endpoint F. Has coordinates X, Y. We know that length of EM should be equal to M F, because M is the midpoint of segment EF. I want you to imagine that this part is equal to this, okay? So now we need to find the length of the segment EF. Because we don't have coordinates of F, we will use midpoint to find these coordinates first. So let's use midpoint formula to find xy coordinates. So we know that the coordinates of midpoint of a segment are averages of the x coordinates and of the y coordinates of the endpoints. So our midpoint, we can write, has coordinates. First coordinate of midpoint is sum of x coordinates of endpoints divided by 2. So we have 0 plus x over 2, and the second coordinate of midpoint is sum of y coordinates of endpoints divided by 2. So we have negative 2 plus y over 2. And we have given that first coordinate of midpoint is 18 and the second is 4. It means that 0 plus x over 2 must be equal 18 because this is first coordinate, and negative 2 plus y over 2 is our second coordinate, should be equal 4. So we have two equations. Unknown is x and y. So we have to solve these two equations to find endpoint F coordinates. So we have, let me copy this one more time. We have 0 plus x, so this is x over 2 equals 18. I will multiply both sides by 2 to reduce the denominators. So we have x is equal 18 times 2 is 36. And we have the second equation, negative 2 plus y over 2 is equal 4. I will multiply by 2 both sides to reduce the numerator. So we have negative 2 plus y is equal 4 times 2 is 8. Negative 2 I will move to the right side, so we have y is equal 8 plus 2, so y is equal 10. We have y and we have x. So now we know that our endpoint F has coordinates 36, 10. When we have coordinates of endpoints E and F, we can use distance formula to find the length of segment EF. So let me remind you this formula. When we have 2 points, the distance between these 2 points is EF is equal square root of, in first parenthesis we have difference of first coordinates of endpoints. So we have x2 minus x1 to second power plus, and in the second parenthesis we have difference of second coordinates of endpoints, y2 minus y1 to second power. So this is equal, let's first write in this corner we have E, so we have F, so E is 0, negative 2, and we have distance EF, so our first endpoint is x1, y1 has coordinates, and F has x2, y2. So now from x2 we have to subtract x1, so we have in parentheses 36 minus 0 to second power plus, and we have y2 minus y1, so we have 10 minus negative 2 to second power. So this is equal, we have square root of 36 to second power plus negative and negative give us positive, so we have 10 plus 2, so this is 12 to second power. So this is equal, we have square root of 36 to second power is 1296 plus 12 to second power is 144. So this is equal square root of 1440. So this is equal approximately 37.9 units, of course. So this is my solution. Find the length of segment with given endpoint G and midpoint M. We have given G and M, so we can draw XY plane first. We have negative 9, so let's choose small unit 1. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and 5. 1, 2, 3, 4, 5. So our point G is approximately here. Negative 9, 5. We have midpoint 3, negative 1, 1, 2, 3, negative 1. So this is approximately here. This is our midpoint 3, negative 1. We can connect these 2 points because M is midpoint of segments, so it means that this point divide our segment. Let's put that here will be our H point to 2 equal segments. Length of GM is equal to MH. So because M is our midpoint, it means that the coordinates of the midpoint of segment are the averages of the x coordinates and of the y coordinates of the endpoints. So to find H, we will use midpoint formula. Let's put that H has coordinates x2, y2. So we will have that our midpoint has coordinates. We have to add first coordinates and divide by 2. So we have negative 9 plus x2. We add first coordinates of endpoints and we divide by 2. This is first coordinate of midpoint, and the second coordinate will be, we have to add the second coordinates of endpoints. So this is 5 or our G point and y2, and we have to divide by 2 again. So now we can write equation, because we know that the first coordinates of midpoint is 3 and the second is negative 1. So we have equation that negative 9 plus x squared over 2 is equal 3. This is our first coordinate. And the second equation will be that 5 plus y2 over 2 is equal negative 1. Now we have to find x2 and y2. So we have to multiply both sides by 2 to reduce the numerator. So 2 and 2 will cancel, and we have negative 9 plus x2 is equal 60. 3 times 2 is 6. So x2 is equal 6. We will move negative 9 to the right side, so it will be plus 9. So x2 is equal 15. And now we have to find y2. We will multiply both sides by 2 to reduce the numerator. 2 and 2 will cancel, and we have 5 plus y2 is equal negative 1 times 2 is negative 2. So y2 is equal negative 2. We will move 5 to the right side, so it will be negative 5. So y2 is equal negative 2, negative 5, so it's negative 7. So we got coordinates of our second end point. H has coordinates 15, negative 7. Now we have to use distance formula to find the length of segment GH. Is equal square root of, and in first parenthesis we have difference of the first coordinates. Let's put that our G is x1, y1. So we have x2 minus x1 to second power, plus in the second parenthesis we have difference of second coordinate, so it's y2 minus y1 to second power. So this is equal square root of x2 is equal, this is our x2, y2. Let me write this one more time. So we have x2, 15 minus x1 is our negative 9. So we need to put this in parentheses. We have to second power to raise this. And we have plus y2 is negative 7, and we have minus from this formula, and we have y5 is equal y1. So we have minus 5 to second power. So this is equal square root we have to copy, and in first parenthesis we will have negative, and negative give us positive. 15 plus 9 is 24 to second power, plus, and in the second parenthesis we will have negative 7, negative 5 is negative 12 to second power. So this is equal square root of 24 to second power is 576, plus negative 12 to second power is 144. So this is equal square root of 720. So this is approximately equal 26.8 units. This is my solution. We have given that the length of IM is x over 10, and the length of AB is 3x over 5 minus 8, and M is the midpoint of segment AB. Find length of NB. So first let's draw the segment AB. And we know that M is midpoint, so it means that this point divides our segment to two equals segment. AM, length of AM is equal MB. So what else we know? We know that length of AM is equal x over 10. And we know that AB, length of AB is 3x over 5 minus 8. We need to find length of MB. So let's write equation. Length of AB is equal AM plus MB. What else we know? We know that M is midpoint, like I said. It means that length of AM is equal length of MB. So we can rewrite our equation and we will have that AB is equal, because we have given AM, so I will substitute MB by AM because we know this length. So we have AM, first we have to copy, plus MB is equal AM. So we have now equation that AB, length of AB is equal 2 times AM, because we have AM plus AM, this is equal 2 times AM. Now we can substitute AB, length of AB, by 3x over 5 minus 8. So we have 3x over 5 minus 8 is equal 2 times AM is x over 10. We can reduce 2 and 10 will be 5. So we have 3x over 5 minus 8 is equal x over 5. I will move expression with x to the left side, so we have 3x over 5 and negative 8 to the right side, so we have minus x over 5 is equal 8. Because we have the same denominator, so we can write that we have to copy denominator, and in numerator we will have 3x minus x equals 8. 3x minus x is 2x over 5 is equal 8. Now we can multiply both sides by 5 to reduce denominator. So 5 and 5 we can reduce, and we have that 2x is equal 8 times 5 is 40. Now we divide both sides by 2 to reduce 2, and we have that x is equal 40 divided by 2 is 20. We have x. We have to find MB, and we know that MB is equal AM, and AM is equal x over 10. We found x. X is equal 20, so we have 20 over 10, so this is equal 2. So the length of MB is equal 2. This is my solution. Bill is a salesperson. He visits cities P, R, and S. Bill travels along the road shown on the map below. So we had that distance PR is 25.6 kilometer, and RS is 2 times PR. So let's put that this is our 25.6, and from R city to S is 2 times PR, so we have 2 times PR, so this is equal 2 times 25.6 kilometer, of course. Have to add here kilometer. And what we have to find? We have to find the distance Bill travels if he starts at city P and visits city R and S, then return to city P. So he starts to city P, go to city R, next to city S, and next return to city P. So the distance, let's put that D is our distance, is equal PR, distance from city P to city R, plus distance from city R to S, so RS, and next Bill returns from city S to P. So again we have RS distance and PR. So we have again plus RS plus PR. So we have that D is equal, we have 2 times PR, you can combine the like terms, and we have 2 times RS. We know that RS is 2 times PR, so we can rewrite this, that this is equal 2 times PR plus 2 times and RS, we can substitute by 2 PR. So this is equal 2 PR plus 2 times 2 is 4 PR, so this is equal 6 PR. Now we can substitute PR by 25.6 kilometer. So we have 6 times 25.6 kilometer. So this is equal 153.6 kilometers. So this is our distance. Now we have to find how much time does Bill spend driving if his average driving speed is 60 kilometers per hour. So we have distance. So we know that the velocity V is equal 60 kilometers per hour. And we know that formula for the velocity for the speed is equal distance over time. We have distance, we have velocity, the speed. So now we have to find only time from this formula. We can do cross multiplication. We can put that this over 1. So we have proportion V times delta t is equal 1 times delta d. So this is delta d. Next, because we need to find delta t, the time, so we have multiplication here. So we will divide both sides by v, by velocity. V and v we can reduce, and we have that time is equal distance over velocity. So now we can substitute distance is equal 153.6 kilometers. Velocity, the speed, is 60 kilometers per hour. So kilometers and kilometers we can reduce, and we have to divide 153.6 divide by 60. So we can write that this is approximately 2.6, and we have in numerator kilometers we reduce, so we have 1 over kilometers is reduced, so we have 1 over hour. So this is equal 2.6 hour. Let's go to question C. Bill needs to spend 2 hours in each city. Can he visit all 3 cities and return to city P in 7 hours? So we know that he needs 2.6 hours to travel from city P to city R, next to city S, and next to return to city P. So this is the time which he needs. What else? We know that he spent 2 hours in each city. So we have 2 hours in city P, 2 hours in city R, and 2 hours in city C. So when we add this time, we will have, let's write this, we have 3 times 2 hours, and we have to add the time which he drive. So we have 2.6 hours. So this is equal 6 plus 2.6, so this is 8.6 hours. So we see that this is more than 7 hours. So it means that he cannot return to city P in 7 hours. This is my solution. Tell wherever the angle appears to be acute, obtuse, right or straight. First, let me remind you, we have acute angle when the measure of angle is between 0 and 90 degrees. We have obtuse angle when measure of angle is between 90 and 180 degrees. And the right angle has 90 degrees and straight angle has 180 degrees. We have to use protractor, and we know that protractor can be used to approximate the measure of angle. An angle is measured in units called degrees. So first we have to find the measure of angle AEC. Let's find this angle. We have angle AEC. To find the measure of angle AEC, we have to put first our point in vertex of our angle, and now we have to put our rays EC on 0 degrees, and now we are going to the second ray EA. So we are going to 70 degrees. So our angle AEC is 70 degrees. It means that we have acute angle. Why? Because the measure of this angle is between 0 and 90 degrees. Next, we have angle BDC. So we have to find D, and we have BDC. So first we have to put our point in vertex D. The ray BD has to be on 0 degrees, and we are going to the second ray DC is here. So we are going to, we can write 80, here is 90 degrees, so like 85 approximately degrees. Our angle BDC has 85 degrees approximately. So again, because the measure of this angle is between 0 and 90 degrees, so we have acute angle again. Next we have angle AEB. So we have to find E and AE, and we have EB. The first ray is EA. So we have to put our point on vertex E, and we have the first ray EA on 0 degrees, and we are going to 110 degrees. So we have that our angle has 110 degrees. The measure of this angle is between 90 and 180 degrees, so it means that we have obtuse angle. Next, we have angle ABC, so we have to find B, and we have ray BA and BC. So we have to put our point of our projector of vertex B, and first ray BA is on 0 degrees. We are going from 0 to, we can write approximately 54 degrees we have. So again we have acute angle. Now we have angle ACB. So our vertex is in C point, so our point of our protractor has to be at C, and 0 degrees we will put at CA, and now we are going to the second ray. CB is on 90 degrees exactly. So we have right angle. This is 90 degrees. Right angle has 90 degrees. And now we have angle EFA. F, we have EFA. So we see we don't have to measure this angle. This angle has 180 degrees, but we can always check. We have to put the point of our projector of F, and now the one ray is on 0 degrees, and we are going to the second ray EF is on 180 degrees. So for sure we have 180 degrees angle with a straight angle. This is my solution. We have to find the measure of angle ADC. We have given diagram angle ADC we have, and we have given point B. B is the interior point. So when B is the interior point of angle ADC, then the measure of angle ADC is equal to the sum of measures of angle ADB and BDC. So we can write that measure of angle ADC is equal measure of angle ADB plus measure of angle BDC. So this is equal. We have given that measure of angle ADB is 42 degrees. So we can substitute this. And we have measure of angle BDC is 57 degrees. So this is equal 99 degrees. This is my solution. We have to find the measure of angle KLP. So we have to find this angle. What we have given here? We have that angle PLM has measure 49 degrees. So we can write this, that measure of angle PLM is 49 degrees. What else we have here? That we see that angle KLM is straight angle. And we know that measure of straight angle is 180 degrees. So let's write this. KLM is equal 180 degrees. So we know that angle KLM is straight, has 180 degrees. We have given angle PLM, so now to find angle KLP, we have to subtract from angle KLM, from straight angle, angle PLM. So we can write equation first, that measure of angle KLM is equal measure of angle KLP plus measure of angle PLM. Now we can substitute measure of angle KLM is 180 degrees. This is equal. We have to find measure of angle KLP, and we have given that angle PLM is 49 degrees. So we have plus 49 degrees. So now we will move 49 degrees to the left side. So we will have 180 degrees minus 49 degrees. This is equal angle KLP. So we can write first that measure of angle KLP is equal 131 degrees. This is my solution. Now we have to find measure of angle ABC. So let's put that this is our green. This angle we have to find. We have given that angle DBC is 42 degrees. So we can write that measure of angle, or in other words, we can write that angle CBA has 42 degrees. CBD has 42 degrees. And what else? We have given here this square. It means that angle ABD is right angle. And we know that right angle has 90 degrees. So we know that measure of angle ABD is equal 90 degrees. So now we can write equation that measure, because C is interior point, so the sum of these two angles is equal to measure of angle ABD. So we have that measure of angle ABD is equal measure of angle ABC plus measure of angle CBD. So now we can substitute that measure of angle ABD is 90 degrees. Like I said, we have a square here. It means that this angle is a right angle, so has 90 degrees. This is equal. We have to find measure of angle ABC, and we have given that angle CBD has 42 degrees. So our angle ABC will be 90 degrees minus 42 degrees. We will move this 42 degrees to the left side, so we have to change this sign. So we have 90 degrees minus 42 degrees. So this is our angle ABC. So I can change the sides, and we have measure of angle ABC is equal 90 degrees minus 42 degrees, so it's 48 degrees. This is my solution. We have given that measure of angle CDA is 70 degrees. So this angle has 70 degrees. We have to find angle BDA. And what else we have given? That angle CDB is 2x plus 17 degrees, and angle BDA has 5x minus 17 degrees. So we have unknown x. We have to find this unknown x to find the measure of angle BDA. Because B is interior point, it means is between points that lay on each side of the angle. We can write that measure of angle CDA is sum of two angles CDB and BDA. D is our vertex of our angle. So we have that measure of angle CDA is equal to sum of angles M, measure of angle CDB, plus measure of angle BDA. What we can do now? We can substitute measure of angle CDA by 70 degrees. Because this is given. So we have 70 degrees is equal, and measure of angle CDB is 2x plus 17 degrees plus measure of angle BDA is 5x minus 17 degrees. So let's forget about degrees now and solve this equation, because we have only one unknown x. So we can find this x. We have on the left side 17. This is equal. We will have 2x plus 17 plus, and we have 5x minus 17. So 17 and 17 we can reduce, and we have 70 is equal 2x plus 5x is 7x. Because we have multiplication on the right side, so we can divide by 7 both sides, and we can reduce 70 with 7 will be 10. So, and 7 and 7, so we have that x is equal 10. So now we can come back to our expression of angle BDA, because we have to find the measure of this angle. We have that measure of angle BDA is equal 5x minus 17 degrees. So this is equal. Now, because we found that x is equal 10, we can substitute this x, so we have 5 times 10 minus 17 degrees. So this is equal 50 minus 17. So this is equal 33 degrees. So we found that our angle BDA has 33 degrees. This is my solution. We have given measure of angle ZLX is 150 degrees. So let me put that this angle has 150 degrees. L is the vertex of our angle. What else we have here? Y is interior point of our angle. So we can write that measure of angle ZLX is equal to sum of angles ZLY plus YLX. So we have measure of angle ZLY plus measure of angle YLX. What we have to find here? We have to find x. Now we can substitute measure of angle ZLX by 150 degrees, because this is given. Next, measure of angle ZLY is given 40 degrees. And we have that measure of angle YLX is given by this expression. So we have 3x minus 10 degrees. Let's forget about degrees now. And we have 150 is equal 40 plus 3x minus 10. I just take down this parenthesis, and because we have positive sign before parenthesis, so the sign inside parenthesis stay the same. So we have 150 is equal 40 minus 10 is 30 plus 3x. Now I will move 30 to the left side, so we have 150 minus 30 is equal 3x. 150 minus 30 is 120. This is equal 3x. Next, because we have multiplication on the right side, so we can divide both sides by 3. And we can reduce 3 and 3. 120 divided by 3 is 40. So we have that we can change the sides, so x is equal 40. So this is what we have to find. X is equal 40. This is my solution. We have given that measure of angle KLM is 154 degrees. So we can write that this angle is 154 degrees. What else we have given? We have n, that n is interior point. So we can rewrite that measure of angle KLM is equal to sum of angle KLN plus NLM. Our unknown in this problem is x. We have to find x. So let's first write our equation that measure of angle KLM is equal to sum of measures, measure of angle KLN plus measure of angle NLM. We have given angle KLM is 154 degrees, so we can substitute this. What else? We have given that measure of angle KLN is given by this expression. So we will put this, that we have 3x minus 8 degrees, and measure of angle NLM is x plus 22 degrees. Let's forget about degrees, so we can rewrite our equation that this is 154 is equal 3x minus 8 plus x plus 22. So let's combine the like terms. We will have 154 on the left side, and we have 3x plus x, so this is 4x, and negative 8 and positive 22, so this is equal plus 14. So now I will move positive 14 to the left side, so we will have 154 minus 14, this is equal 4x. 154 minus 14, so this is 140 is equal 4x. Now we can divide both sides by 4 because we have multiplication on the right side. So 4 and 4 we can reduce, and 140 divided by 4 is 35 is our x. So we can rewrite that x is equal 35. We found our unknown x. So now if you want, you can substitute x's and you can find the measure of angle KLN and NLM. But in this example we have to find only unknown value of x. So this is my solution. We have given that ray AB bisects angle CAD. What it means? If ray bisects angle CAD, it means that angle CAB and BAD are congruent. So the measure of angle CAB and BAD is equal. So we can write that measure of angle CAB is equal to measure of angle BAD. What we have to find? We have to find two angle measures not given in the diagram. We have given that measure of angle CAB is 48 degrees. Because, like I said, ray AB divide angle CAB bisects the angle CAB, it means that measure of angle BAD is 48 degrees too. These two angles are equal. So we have one angle. Measure of angle is 48 degrees. We have to find only measure of angle CAD. Measure of angle CAD. And because B is interior point of our angle, so measure of angle CAD is equal to sum of angles CAB and BAD. So measure of angle CAD is equal to measure of angle CAB and measure of angle BAD. So now we have to copy measure of angle CAD is equal. Measure of angle CAB is 48 degrees and measure of angle BAD is 48 degrees too. So we have that measure of angle CAD is equal 96 degrees. This is my solution. We have given that ray AB bisects angle CAD. What it means? That measure of angle CAB and BAD are equal. So let me write this, that measure of angle CAB is equal to measure of angle BAD. What else we have given here? That measure of angle CAD is 105 degrees. So let's write this, that measure of angle CAD is equal 105 degrees. We have to find measure of angle CAB and BAD. But like I said, these two angles, the measure of these two angles is the same. So we can write equation that measure of angle CAD is equal to sum of two angles. Measure of angle CAB and measure of angle BAD. Like I said, these two angles are equal. So now we can substitute. Measure of angle CAD is 105 degrees is equal, because these two angles are equal. So I can substitute measure of angle CAB, that this is measure of angle BAD. So we have measure of angle BAD plus, and we just copy measure of angle BAD. So we have on the left side 105 degrees is equal. We have 2 times measure of angle BAD. So to find measure of angle BAD, we will divide both sides by 2. 2 and 2 we can reduce, and I will change the sides. So we have measure of angle BAD is equal 105 divided by 2. So this is equal 52.5 degrees. So because measure of angle BAD is the same like measure of angle CAB, so we can write that measure of angle CAB is 52.5 degrees too. So this is my solution. We have given that ray AB bisects angle CAD. What it means? That the ray AB divide our angle CAB to 2 angles, and these 2 angles are equal. So measure of angle CAB is equal to measure of angle BAD. So we can write equation, because we have given that measure of angle CAB has expression x minus 15 degrees, and measure of angle BAD has expression x over 3 plus 5 degrees. So we have that x, let me copy this equation maybe first. We have measure of angle CAB is equal to measure of angle BAD. So we have that measure of angle CAB is equal to this expression. So we have x minus 15 degrees is equal measure of angle BAD is x over 5 over 3, of course, plus 5 degrees. So let's forget about degrees. We have to find x first because we need to find the measure of these angles. So we have x minus 15 is equal x over 3 plus 5. I will move expression with x to the left side and without x to the right side. So we have x minus x over 3 is equal, we have on the right side 5, and I will move negative 15 to the right side, so it will be plus 15. So we have x minus x over 3 is equal 20. What I can do now? We have like here 1x. So let me put 1x, we have minus, and we have 1/3 x. This is equal 20. 1 minus 1/3, we can factorize x, and in parentheses we will have 1 minus 1/3. This is equal 20. 1 minus 1/3, you can find the common denominator will be 3 over 3. So we can change 1 to fraction, so 3 over 3 minus 1/3 x is equal 20. We have the same denominator, so we copy denominator and we subtract numerator. We have 3 minus 1 is 2, and x we copy is equal 20. Now we can multiply both sides by 3 over 2 to reduce this fraction. So it will be 3 and 3, 2 and 2 we can reduce, and we have that x is equal 20 with 2 we can reduce, will be 10. 10 times 3 is 30. We have x. So now we have to find measures of our angles. We know that measure of angles CAB and BAD is the same, so we can write that measure of angle CAB is equal measure of angle BAD. So this is equal. You can choose one expression, this or this, it doesn't matter. So we have, let's put this first because this doesn't have fraction. So we have x minus 15 degrees. We found x. So now we can substitute x by 30. So we have 30 minus 15. So this is equal 15 degrees. Our angles CAB and BAD have measures 15 degrees, and we have to find now only measure of angle CAD. Measure of angle CAD is equal to sum of these two angles because B is interior point. So this is equal measure of angle CAB plus measure of angle BAD. And we found these two angles. They have 15 degrees. Let me write this equation maybe first. So we have measure of angle CAB plus measure of angle BAD. So measure of our angle CAD is equal 15 degrees plus 15 degrees. So this is equal 30 degrees. This is my solution. We have given that ray AB bisects angle CAD. What it means? That measure of angles CAB and BAD are equal. So let me write this, that measure of angle CAB is equal measure of angle BAD. And we have given that measure of angle CAB has expression 6x plus 10, and measure of angle BAD has expression 7x. So we can substitute to our equation now. So let's forget about degrees. So we have only 6x plus 10 is equal 7x. Next I will move to the right side 6x because 7 is greater, so I will have positive number on the right and on the left. So we have 10 is equal 7x minus 6x. So we have 10 is equal 6x minus 7x minus 6x is 1x. So we have x. We don't have to put 1 because 1 times x is x. So we had that our x is equal 10. When we have a no x, now we can find the measure of angles. We know that measures of angle CAB and BAD are the same. So let me write this, that measure of angle CAB is equal measure of angle BAD. So this is equal. You can choose one expression, 6x plus 10 or 7x. It doesn't matter. So let's use 6x plus 10. So this is equal 6x plus 10 degrees. Now we will substitute x by 10. So we have in parentheses 6 times 10 plus 10 degrees. So this is equal, 6 times 10 is 60 plus 10 is 70 degrees. So we have measure of angle CAB and BAD. They are equal and have 70 degrees. Let's check. If you substitute, for example, to the second expression x by 10, we will have 7 times 10 degrees, so this is 70 degrees. So it doesn't matter which expression you choose. You should get the same answer. So we have this two angles. So now we have to only find measure of angle CAD. Measure of angle CAD. Because B is interior point of angle CAB, so measure of angle CAB is equal to sum of angles CAB plus measure of angle BAD. And we found that these two angles, they have 70 degrees. So measure of angle CAD is 70 degrees plus 70 degrees. So this is equal 140 degrees. This is my solution. We have to plot the points PR and S in coordinate plane and draw angle PRS. Next, we have to classify the angle. And we have to give example of point that lies in the interior of the angle. So let's first draw XY plane. Because we have only positive coordinates, so we need only first quadrant of our XY plane. Let's choose the unit 1. This is our x-axis, our y-axis. Always the first coordinate is x, the second is y. X, y, x, y. So first point has coordinates 1, 4. 1, and on y we have to find 4. 2, 3, 4. So approximately this is our point P. Next we have R 0, 0. So this is our point R. And point S is 2, 0. For x is 2, 1, 2, and for y is 0. So this point is on x-axis. This is our S. Now we have to draw the angle PRS. It means the vertex is in our point. So this is our vertex. This is our approximately something like this angle. This is our angle PRS. First we have to classify the angle. We have vertex at point 0, 0. So it will be very easy to classify our angle because the second side is in first quadrant, and we know that first quadrant is from 0 to 90 degrees. So this is less than 90 degrees. So it means that our angle is acute. Let's write this. We have acute angle. Because measure of angle PRS is between 0 and 90 degrees. Next, we have to give the coordinates of a point that lies in the interior of the angle. We know that a point is in the interior of angle if it is between points that lays on each side of the angle. So we have to find point which is between side RS and RP. So let's choose, for example, point. First coordinate will be x and the second 1. So let's put that this is our point A and has coordinates 2, 1. This point is between sides RS and RP. So this point is interior point. This is my solution. First we have to plot points PRS. So let's draw XY plane. X-axis, Y-axis, we have to choose unit. First coordinate is always x, the second is y. X, y, x, y. First point is 1, 1, so for x 1, for y 1, so this is our point P. Point R has coordinates negative 1, 1, so this is our point R. And the third point is negative 4, 5. 2, 3, 4, negative 4, and y is 5. So approximately 1, 2, 3, 4, 5 will be here. So our point S is approximately here. Now we have to draw angle PRS. It means the vertex is in point R. This line is this ray PRP is parallel to x-axis because second coordinate is 1 and the second side of our angle is ray RS. We got our angle. This is our angle R, and measure of angle, we can write R or PRS. We see is greater than 90 degrees, because when we draw here parallel line to y-axis, this angle is 90 degrees and we have more than 90 degrees. So our angle is obtuse. So we can write the measure of our angle is greater than 90 degrees and less than 180 degrees. That's why our angle is obtuse angle. We have to find the point that lies in the interior of our angle. Interior of our angle is between ray RP and RS. Any point which you choose from this part of our plane is interior. So let's choose, for example, for x1 and for y3 will be. This is our point A, which has coordinates 1, 3, and this point lies in the interior of our angle, is between side RP and RS. This is my solution. Plot the points PR and S in coordinate plane and draw angle PRS. Classify the angle. Give the coordinates of a point that lies in the interior of the angle. So first we need XY plane. Because we have -4, always the first coordinate is x, the second is y. X, y, x, y. Because we have negative x's and negative y, so we need the third quadrant. So this is our x-axis, y-axis. First we need to find the unit. 1, 1, -1, -1. First point is -4, 0. So -1, 2, 3, 4. -4, 0. So this point is on the x-axis. This is our P. Next we have R is -4 for x and -4 for y. So it's 2, 3, -4. And we have our point R. Next we have to find S. X is 0 and y is -4. So this point is on the y-axis. This is our S point. We have to draw angle PRS. It means R is the vertex of our angle. So let's draw this angle. This line should be parallel to y-axis and this to x-axis. What we got here, because this one line is parallel to y and this ray RS is parallel to x-axis, So we see that our angle R is right angle. So we can write that this is right angle. It means angle R, measure of angle R is 90 degrees. What else? We have to give the coordinates of point that lies in the interior of the angle. So we have to find the point that is in the interior of angle. So we have to find the point which is between points that lie on each side of the angle. So for example, we can choose this point. This point is between sides RP and RS. So let's put that this is our A point 0, 0. Has coordinates. You can choose any point. So this is my solution. First we have to plot the points PRS. So let's draw XY plane. X-axis, Y-axis. We have to choose the unit. We know that first coordinate is X, the second is Y. X, Y, X, Y. First point P has coordinates 1, negative 2. 1 on the x-axis and negative 2. So we have to go down. This is negative 2. So this is our point P. Next, we have to find point R, 1, 1. So this is our R. X is 1, Y is 1. This is point R. And third point is 1, 4. 1 for X and 4 for Y. 2, 3, 4. So this is our point S. We see that these 3 points are on the line which is parallel to y-axis, because the first coordinate is x is 1, 1, 1, 1. So we got straight line. It means that measure of our angle M, measure of our angle P R S is equal 180 degrees. We got straight angle. And now we have to choose point that lays in the interior of the angle. Let's draw this angle. If this is our angle PRS, so the point which is between ray RP and RS. You can choose any point which is between these 2 sides. So, for example, let's choose A, which have first coordinate 2, because we have 1, 2, and second coordinate negative 1. This is our example of interior point. This is my solution. We have given diagram. We know that measure of angle KOL is 1/2 of measure of angle NOM. We have to find measure of angle KOL and measure of angle NOM. What else we have given here? This red square here tells us that angle LON is the right angle. It means that measure of angle LON is 90 degrees. What else we have here? KOM, they are on straight line. It means that angle KOM is straight angle. It means that has measure 180 degrees. So we can write that measure of angle KOM is 180 degrees. What else? We can write equation that measure of angle KOM is sum of these three angles KOL, LON and NOM. Why? Because L and N are interior points. So we can write equation that measure of angle KOM is equal measure of angle KOL plus measure of angle LON and measure of angle NOM. What else? We have given that measure of angle KOL is 1/2 of measure of angle NOM. So we can now substitute in our equation first. Measure of angle KOM is 180 degrees. This is equal. Measure of angle KOL, like I said, is 1/2. So we can write 1/2 measure of angle NOM. And next, measure of angle LON is 90 degrees. So we have plus 90 degrees. And we have measure of angle NOM. We see that we got equation and we have only one unknown, measure of angle NOM. NOM we have. So we can now combine the like terms. And I will move 90 degrees to the left side. So we will have 180 degrees minus 90 degrees. So this is equal. And we can combine the like terms. We have 1/2 and like here is like 1 angle NOM. So 1 and 1/2. So we can write that this is 3/2 times measure of angle NOM. 180 minus 90, so this is 90 degrees, is equal 3/2 measure of angle NOM. Now we need to find measure of angle NOM. So now I will multiply both sides by 2/3 to reduce this fraction. So this whole fraction we can reduce, and we have 3 and 90, so will be 30 degrees. So 2 times 30 degrees give us 60 degrees, and this is equal measure of our angle NOM. We found that measure of angle NOM is 60 degrees. Now we have to find measure of angle KOL because we found this angle, and we have this equation. The measure of angle KOL is 1/2 of measure of angle NOM. So our angle KOL is equal 1/2 of measure of angle NOM. So now we will substitute because we found measure of angle NOM. So 1/2 we copy and we have times 60 because this is our angle NOM. So we have 1/2 times 60 degrees. So we can reduce 2 with 60 will be 30 degrees. So we have measure of angle KOL is 30 degrees. So we found these two angles which we have measure of angle KOL and measure of angle NOM. So we solved our problem. We have to find the measure of complement and supplement of angle 1. Angle 1 has measure 37 degrees. So this is less than 90 degrees. So this angle is acute. We can draw this angle. So this is approximately 37 degrees. This is our angle 1. And we have to find first complement of this angle. We know that two angles are complementary angles if the sum of their measures is 90 degrees. So 90 degrees is right angle. So let's draw this right angle. This approximate would be this is our 90 degrees angle, and the angle complement of angle 1, let's put that this is our angle 2, because we know that two angles are complementary angles if the sum of measures is 90 degrees. So we can write that we have equation here that measure of angle 1 plus measure of angle 2 must be 90 degrees. We have given measure of angle 1 is 37 degrees, so we can substitute plus measure of angle 2. So this is equal 90 degrees. So now I will move 37 degrees to the right side. So we had that measure of angle 2 is 90 degrees minus 37 degrees. So this is equal 53 degrees. So we found that measure of angle 2, which is complement of angle 1, is 53 degrees. So we found the measure of complement of angle 1. Now we need to find supplement of angle 1. Let me remind you that two angles are supplementary angles if the sum of their measures is 180 degrees. So let's draw one more time our angle 1, which has 37 degrees. So this is acute angle. Approximately here is less than 90 degrees. This is angle 1. And to find supplement of angle 1, we have to get angle 180 degrees. 180 degrees is straight line. So we have to get straight line. This is our supplement of angle 1, this part. So let's put that this is our 3. And let me write this. Here we have 90 degrees when we have to find complement, and when we have to find supplement, we have to have 180 degrees. This angle has 180 degrees. So now we can write equation that measure of angle 1 plus measure of angle 3 should give me 180 degrees. We know the measure of angle 1 is 37 degrees. We have to copy angle 3. So this is 180 degrees. Now, to find measure of angle 3, our supplement of angle 1, we will move 37 to the right side. So we have measure of angle 3 is 180 degrees minus 37 degrees. So this is equal 143 degrees. So we found supplement of angle 1 and complement of angle 1. This is our complement. And this is our supplement. Of angle 1. This is my solution. We have to find measure of complement and supplement of angle 1. We have given that measure of angle 1 is 85 degrees. So let me draw this angle. 85 degrees is little less than 90 degrees, so something like this approximately. This is our angle 1. And we know that two angles are complementary angles if the sum of their measures is 90 degrees. So let's draw angle 90 degrees. Will be approximately here. So the complement of angle 1, let's put that this is our complement, will be 2. Angle 2 is complement of our angle 1. So to find measure of complement of angle 1, let me put that this is ours as 90 degrees. So we can write equation that measure of angle 1 plus measure of angle 2 must be 90 degrees. If angle 2 is complement of angle 1, the sum of these two angles must be 90 degrees. We know that measure of angle 1 is 85 degrees, so let me substitute this. Plus measure of angle 2 must be 90 degrees. Now I will move 85 degrees to the right side. So we have measure of angle 2 is 90 degrees minus 85 degrees. So this is 5 degrees. We found complement of angle 1. Now we have to find supplement. So let me draw one more time this angle. We have angle 85 degrees. Angle 1, so like I said, is very close to right angle, but a little less. This is our angle 1. And we know that two angles are supplementary angles if the sum of their measures is 180 degrees. So 180 degrees is straight angles. So we have to draw straight line. This is our 180 degrees angle. So we need to find this angle. Let's put that this is our tree. This is our supplement of angle 1 because two angles are supplementary angles if the sum of their measures is 180 degrees. So we have this straight angle. So let me write that measure of angle 1 and measure of angle 3 must be 180 degrees. We know measure of angle 1 is 85 degrees. We have plus measure of angle 3, this is 180 degrees. So now I will move 85 to the right side. So we have measure of angle 3 is equal 180 degrees minus 85 degrees. So this is equal 95 degrees. So this is our supplement of angle 1. This is my solution. We have given diagram and we know that measure of angle ABC is given by expression 5x minus 27 degrees and measure of angle CBD is given by expression 14x plus 17. We have to find measure of angle ABC and CBD. What we see here? We see that angle ABD is straight angle. So the straight angle has 180 degrees. This is our 180 degrees. We can write equation that measure of angle ABD is equal to sum of measures of angle ABC plus measure of angle CBD. ABC plus CBD. So now we can substitute a measure of angle ABD by 180 degrees because this angle is straight angle. So we have 180 degrees is equal, and measure of angle ABC is given by this expression. We have 5x minus 27 degrees plus measure of angle CBD is given by expression 40x plus 17. So let's forget about degrees and we can rewrite our equation. 180 is equal 5x minus 27. We can take down the parentheses and we have positive sign, so we copy exactly the same what we have in parentheses. Now we can combine the like terms. So we have 180 is equal 5x plus 14x is 19x, and we have negative 27 plus 17, so this is negative 10. So now I will move negative 10 to the left side, so we will have 180 plus 10 is equal 19x. 180 plus 10 is 190. This is equal 19x. Now because we have multiplication on the right side, I will divide both sides by 19 because we need to find x. So 190 divided by 19 is 10. 19 and 19 we can reduce and we have 10 equals x, so we can change the signs and we have x is equal 10. We have x. So now it will be very easy to find our angles. We need to find measure of angle ABC and CBD. CBD. How we can do this? We can substitute x's by 10 and we will have measure of angles, or we can find one angle, for example ABC, and because we know that this angle is 180 degrees, so we can subtract from 180 degrees measure of these angles and we will have measure of angle CBD. It doesn't matter which way you choose, the answer must be the same. So let's substitute x by 10 to the first expression and we will have that measure of angle ABC is equal, let me copy this first expression first, we have 5x minus 27 degrees. So now I will substitute x by 10, so we have 5 times 10 minus 27 degrees. So this is equal 50 minus 27 degrees. So this is equal 23 degrees. Like I said, you can substitute x in the second expression to find angle CBD, or you can subtract from 180 this 23 degrees and we will have this obtuse angle. So let's use the second method. So measure of angle CBD is equal 180 degrees minus measure of angle ABC. So this is equal 180 degrees minus, we have measure of angle ABC as 23 degrees. So this is equal 157 degrees. So this is my solution. We have given diagram and measure of angle ABC is given by expression 3x and the measure of angle CBD is given by expression 7x degrees. So what else we have given here? We see that measure of angle DBE is 90 degrees. This red square means that we have here 90 degrees. What else we have here? Because ABC lay on the straight line, it means that angle ABE is straight angle, so this is 180 degrees. So it means that angle ABD is right angle because we have 180 minus 90, so give us that the angle ABD is right angle too. So we can write that this is 90 degree too. So we can write equation that measure of angle ABD is 90 degrees and we can rewrite this angle to sum of these two angles because point C is interior point. So measure of angle ABC, measure of angle ABD is equal to measure of angle ABC plus measure of angle CBD. Now we can substitute measure of angle ABD is 90 degrees and measure of angle ABC is given by this expression 3x degrees plus measure of angle CBD 7x degrees. Let's forget about degrees first, so let me rewrite equation one more time. We have 90 is equal 3x plus 7x. So we have that 90 is equal 7 plus 3, so this is 10x. Now we will divide both sides by 10. So we have that x, we can change the sides, is equal to 90 divided by 10, so 0 we can reduce, so we have 9 divided by 1 is 9. We have x. So now to find the measure of angle ABC and CBD, we can substitute x by 9 and we will have measures of these angles. So measure of angle ABC is equal 3x degrees. So this is equal 3 times 9 degrees. So this is equal 27 degrees. And measure of angle CBD is equal 7x degrees. So this is equal 7 times 9 degrees. So this is equal 63 degrees. This was one method. Or if you have measure of angle ABC, you can subtract from 90 degrees 27 degrees and you will get the same answer. This is my solution. We have given diagram. On the diagram we have two lines which cross at one point. And we have to find values of A and B. What we see here, because these two lines cross in one point, it means that angles which have the same vertex and not the same sides are equals. It means the measure of angle given by expression 2A degrees and 3B degrees are equals. And the measure of angle 8A plus 30 degrees is the same like this angle, which we don't have here. So this is 8A plus 30 degrees. So we have two unknowns, so we need two equations. First equation 3b degrees is equal to a degrees. What else? Because here we have straight line, it means that these two angles are supplementary angles. It means that the sum of their measures is 180 degrees. So we have another equation 8a plus 30 degrees plus 2a degrees is equal 180 degrees. So we have two equations and two unknown. In the second equation we have only one unknown a, so we first solve this equation. So let's forget about degrees at the beginning. Let me copy first equation. We have 3b is equal to a. And in the second equation we can rewrite and take down this parenthesis. So it will be 8a plus 30 and we have plus 2a is equal 180. So let's copy first equation. We have 3b equals 2a and in the second equation we have 8a plus 2a, so it's 10 8a, and I will move 30 to the right side, so it will be 180 minus 30. So we have that 10a is equal 150. So now we divide both sides by 10 because we need to find a. So we have that a is equal 15. We have a value of A. Now, to find the value A of B, we will substitute A by 15 in the first equation. So we have 3B is equal 2 times 15. So we have 3B is equal 30. Now I will divide both sides by 3. So we have B is equal 30 divided by 3, so this is 10. We found value of A and value of B. So we solved our problem. We have to find values of X and Y. We have given diagram. On this diagram we have two lines which cross in one point. We know that when two lines cross in one point, the angles which are across are the same. This angle and this have the same measures, and this, that is different color, and this 3x plus 37 is the same like y plus 7. What else we see on this diagram? We have, like I said, two lines. Let's choose this line. We see that this line gives us straight angle, and straight angle has 180 degrees. So the sum of these two angles, because they are supplementary, is 180 degrees. So we have equation that y plus 7 degrees plus 2y minus 7 degrees is equal 180 degrees, because these two angles are supplementary. So we have equation with one unknown. Let's forget about degrees first. So we have y plus 7 plus 2y minus 7 is equal 180. Y, now we can combine the like terms. Y plus 2y is 3y, 7 and negative 7 we can reduce, is equal 180. Now we will divide both sides by 3. 3 and 3 we can reduce, and we have that y is equal 60. So next we have to find x. We have y. We can use two methods. We know that these two angles are the same and these two are the same. So we can write that y plus 7 is equal 3x plus 37. Y we have, so we will have only one unknown x. Or we can use again supplementary angles, because we see that 3x plus 37 and 12x minus 7 give us angle 180 degrees. So these two angles are supplementary angles. So we can again write equations something like this. We have two methods to find our x. It doesn't matter which you choose. The answer will be the same. Let's put now that angle 3x plus 37 is equal y plus 7 degrees. Let's forget about degrees. So we have 3x plus 37 is equal y plus 7. I will move 37 to the right side, and we have given that y is 60, so we can substitute. We found that y is 60, so we can substitute. So we have 3x is equal y is 60 plus 7 minus 37. So 3x is equal 30. So now we divide both sides by 3. So we have x is equal 10. We found values of x and y. So this is my solution. We have given that angle ABC is complement of angle PBS, and PBS is a supplement of angle KLM. Let measure of angle ABC is 8 degrees. What is the measure of angle KLM? So let's first draw the graph. We have given that angle ABC is complement of PBS. What it means? It means that the sum of these two angles is 90 degrees. So let's draw first angle ABC. It must be acute angle because we know that this angle is complement of PBS. So it means that they are together give us 90 degrees. So we have approximately like this. This is our angle 90 degrees because angle ABC is complement of an angle PBS. And this is our vertex B. This is angle ABC, and this is angle PBS. What else we have given? We have given that P, of course here we have P. What else we have given? We have given that angle PBS is supplement of angle KLM. So it means that the sum of angles PBS and KLM give us straight angle. It means 180 degrees. So this is our straight line, straight angle will be. So let's put this green. This is our angle 180 degrees. And this is angle K. It means that B is equal to L M. What else we have here? We have that measure of angle A, B, C is 8 degrees. So let's put that this is our degrees. So now we have to find measure of angle KLM. We have to find measure of angle KLM. This is our unknown. Let's put that this is our blue. KL. This is our angle which we have to find measure of angle KLM. Let's start from the beginning. We know that angle ABK is right angle, and we know measure of angle ABC. So we can find the angle PBS. Let's write, we have that measure of angle AB PBS is equal measure of angle ABC plus measure of angle PBS. So measure of angle ABC is 90 degrees because angle ABC and PBS are complement. So the sum of two angles is 90 degrees. So we have 90 degrees is equal measure of angle ABC is given that this is A degrees, and PBS, measure of angle PBS is our unknown. So we can move A degrees to the left side. So we have that 90 degrees minus 8 degrees is equal measure of angle PBS. So if we have now this angle, because we can change the sides and we have that measure of angle PBS is equal 90 degrees minus 8 degrees. So we have this angle PBS. So now, because angle PBS and KLM are supplementary angles, it means that the sum of these two angles is 180 degrees. So we can write that measure of angle KLM is difference of angles, because we have angles 180 straight angle and we have given this part, so the angle KLM it will be 180 degrees minus this part. So we have that measure of angle KLM is equal 180 degrees. Why? One more time, because angle PBS and KLM are supplementary angles. So the measure of these two angles is 180 degrees. So the measure of angle KLM will be 180 minus measure of angle PBS. So we have that measure of angle KLM is equal 180 degrees minus, and measure of angle PBS, we just found that this is, let's put it in parentheses because we have negative sign before this expression. So we have 90 degrees minus 8 degrees. So we have that measure of angle KLM is equal 180 degrees minus negative sign we have before parentheses, so we have to change the sign, will be minus 90 degrees, negative and negative give us plus 8 degrees. So the measure of angle KLM is 180 minus 90, so this is 90 degrees plus 8 degrees. So we found measure of angle KLM because A was given at the beginning. So this is my solution. Tell wherever the figure is polygon and wherever it is convex or concave. First, what is polygon? Polygon is a closed plane figure bounded by straight lines. So let's see. In our first example, we see that this figure is bounded by straight lines. All sides are straight. This is polygon. And what else we can say about this polygon? Because this straight line, when you extend this straight line and this and that, we see that any of these lines will not pass interior of our polygon. So we have here convex polygon. So we can write that this is convex polygon. We have next example. First, we see that we have here curve. And we know that a polygon is a closed plane figure bounded by straight lines. If any of side is curved, like in this example, then is no longer a polygon. So this is no polygon. We can write that it is not polygon. Next, we have plane figure that is bounded by straight lines. So this is polygon. And what else? If you extend this straight lines, for example, I can extend this straight line, we see that this line passes interior of our polygon. If the line passes interior of our polygon, then it is not convex polygon, it is concave polygon. Next example, we have here closed plane figure bounded by straight lines. What else? Because in this example, these sides, when we extend, we see that we cross another side, and this side, when we extend this side, we will cross another side, and we create two smaller polygons. So this is not convex or concave polygon. When polygon is neither convex nor concave, we say that this is complex polygon. Complex polygon intersects itself. So next example, we have here polygon. Why? Because we have closed plane figure bounded by straight lines. What else? When you extend the straight lines, we will not pass interior of our polygon. We will not pass. So it means that we have here convex polygon. In next example, we have open figure. This plane figure is not closed, so it is not polygon. Next, we see here that this segment, for example, intersect more than two sides. We intersect this side, that, and that. So this is not polygon. And the last example, we have here closed plane figure, and this figure is not bounded by straight lines. We have here curve, so this is not polygon. This is my solution. We have to classify the polygon by the number of sides. So we have first example. Let's count. We have 1, 2, 3, 4 sides. So we have quadrilateral. Let's write this. Next, we have to tell if the polygon is equilateral, equiangular, or regular. We know that equilateral polygon has all sides equal. We see that these three sides are congruent, but that side is not. So this is not equilateral polygon. What else? Because these angles are different. We have only these two angles congruent and that two angles congruent. So this is not triangular polygon. So this is not regular polygon, we can write. And we know that a regular polygon is convex polygon that is both equilateral and equiangular. This polygon is not equilateral and is not equiangular. So we can write that this is not equilateral and not equiangular. So it's not regular polygon. Now we have to check if our triangle is regular polygon. A regular polygon is a convex polygon that is both equilateral and equiangular. Our polygon is convex. Why? Because if you extend the sides of our polygon, every side not contain the interior of our polygon. So this is convex polygon, and because this is equiangular polygon and equilateral, so this is regular polygon. We can write regular triangle. Next, we have polygon which has 1, 2, 3, 4 sides. So again we have quadrilateral. What we have next? We have to check the sides. The sides are the same. So we have polygon which is equilateral. So we can write that we have equilateral polygon. Let's check now the angles. The angles which are across are the same, but not all of these interior angles. The interior angles are different, so we don't have here equiangular polygon. It's not. And because this quadrilateral is not equiangular, it is not regular quadrilateral. So we can write polygon or quadrilateral. This is my solution. We have to classify the polygon by the number of sides first. We have 1, 2, 3, 4 sides, so we have quadrilateral. That's right. Next, we have to say if it's equilateral, equiangular, or regular polygon. We know that equilateral polygon has all sides congruent. We see that only the sides which are across are congruent. So this is not equilateral polygon. Next, we have to check the angles. When we have to check if polygon is equiangular, we need to check angles. We have these squares. So it means that all these angles have 90 degrees. So the angles, interior angles of our polygon are congruent. It means that our polygon is equiangular polygon. Next, we have to check if our quadrilateral is regular polygon. We know that regular polygon is a convex polygon that is both equilateral and equiangular. Our polygon is convex because when you extend every side of our polygon, the side will not contain the interior of our polygon. So this is convex polygon, but because this polygon is not equilateral, so it is not regular polygon. We have next example. First, we have to count the sides. We have 1, 2, 3, 4, 5, 6 sides. So we have here hexagon, what else? We see that the sides are congruent. It means our polygon is equilateral polygon. And because all interior angles are different, so this is not equiangular polygon. Next, we have to check if our hexagon is regular polygon. We know that regular polygon is a convex polygon that is both equilateral and equiangular. Because our hexagon is not convex, because when you extend, for example, this side, we see that our line will pass interior of our hexagon. So it is not convex polygon. Because this is not convex polygon, it is not regular polygon. In the next example, we have 1, 2, 3, 4, 5, 6 hexagon again, because this polygon has 6 sides. So this is hexagon. Next, we have to check if our polygon is equilateral. Equilateral polygon has the same sides, because we don't have here any numbers or the segment. It means the sides are different, so this is not equilateral hexagon. Next, we have to check the angles. Because we have this mark, it means that our angles are the same. So our polygon is equiangular. Next, we have to check if we have regular polygon. We know that regular polygon is convex polygon first. We have to check. Because if you extend the sides of our polygon, every side will not pass interior of our polygon. So this is convex polygon, and because it is not equilateral polygon, we don't have equal sides, it is not a regular polygon, because regular polygon must be convex polygon and must be equilateral and equiangular. So it is not regular polygon. Polygon, or you can write it is not regular hexagon. This is my solution. We have to classify the polygon by the number of sides. So first let's count. We have 1, 2, 3, 4, 5, 6 sides polygons, so we have hexagon. Next, we see that all these sides are congruent, so it means we have equilateral polygon, or we can write hexagon. Next, we have to look inside to our hexagon. Interior angles are the same, so we have equiangular polygon, or we can write equiangular hexagon. Next, we have to check if we have regular polygon. With regular polygon is convex polygon that is both equilateral and equiangular. This polygon is our hexagon, is equilateral and equiangular. So now we have to check if it is convex polygon. What it means, when you extend the sides of our polygon, every line will not pass interior of our hexagon. So we have convex polygon. It means that we have regular polygon. We can write regular hexagon. Next, we have polygon. Next, we have polygon which has 5 sides. So it means we have pentagon. Next, we have to check if it is equilateral and equiangular polygon. Equilateral polygon has all sides congruent, equals, it means. We see that our pentagon has sides 2 meters. Every side has 2 meters, so it is equilateral pentagon. Next, angles of our pentagon are the same. So we have equiangular pentagon because equiangular pentagon has all interior angles the same, congruent. So we have equiangular pentagon. Next, we have to check if it is regular pentagon. Regular pentagon is convex polygon that is both equilateral and equiangular. In the convex polygon, when you extend the sides, when you draw the line which pass side of our pentagon, every line will not pass interior of our pentagon. We will not pass interior of our pentagon. It means that this pentagon is convex polygon, and because it is equilateral and equiangular pentagon, so we have regular pentagon. And the last example, first we have to count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 sides, so it means that we have dodecagon. Next, we have to check if it is equilateral polygon. Equilateral polygon has the same sides. All sides are congruent. Because we have this mark, it means that these sides are the same, so we have equilateral dodecagon. Next, we have to check interior angles. Because we don't have here any marks and we see that this angle is not the same like that, interior angles are different, so it is not equiangular dodecagon. Now we have to check if our polygon is regular polygon. We know that regular polygon is convex polygon that is both equilateral and equiangular. Because this polygon, our dodecagon, is not equiangular, so for sure it will be not regular polygon, and also when you extend the sides of our polygon, for example, when you extend this side, we will pass interior of our polygon. So it is not convex polygon. So it is not regular polygon. Polygon, or we can write it's not regular dodecagon. This is my solution. A table is shaped like a regular hexagon. The expression 6y degrees and 7y minus 20 degrees represent the measures of two of the angles of the hexagon table. Find the measure of the angle of the table. We have given here regular hexagon. It means that the sides are congruent and all angles in the interior of the hexagon are congruent. It means that our angles, which we have given by expressions 6y degrees and 7y minus 20 degrees, are equal. So we can write equation, because we have one unknown y, it means that we need one equation to find this unknown. So we have that 6y is equal 7y minus 20. Why? Because we have regular hexagon, and in the regular hexagon the angles are the same. So now we have to solve this equation. I will move 7y to the left side, so we have 6y minus 7y is equal negative 20. 6y minus 7y is negative y is equal negative 20. Now I will divide both sides by negative 1. So negative and negative give me positive. And we have that y is equal 20. So now when we have unknown y, we can calculate the measure of angle of a table. We can choose expression 6y degrees or 7y minus 20 degrees. It doesn't matter, because whatever you choose, you have to get the same answer. So let's choose 6y degrees. We will have 6y degrees is equal, I will substitute y by 20, so we have 6 times 20 degrees. So this is equal 120 degrees. And if you choose the second expression, we will have 7 times 20 is 140 minus 20 is 120 degrees. So whatever you choose, you have the same answer. So we found the measure of angle of the table. It is 120 degrees. We have formula that the measure of angles of regular polygon is 180 degrees times n minus 2, where n is number of sides. In this example, we have regular hexagon, so we have 6 sides. So n is equal 6. So now we can substitute n by 6, and we have 180 degrees times 6 minus 2. So this is equal 180 degrees times 6 minus 2 is 4. So this is equal 720 degrees. This is measure of angles, interior angles for regular hexagon. we need in this example to find measure of angle, only one angle. So now we have to divide 720 by 6. When you divide 720 by 6, you have exactly 120 degrees. So we got correct answer. This is my solution. The expressions 11x minus 25 and 9x plus 5 represents the length of two sides of equilateral pentagon. Find the length of side. We have here equilateral pentagon. It means that all sides of pentagon are congruent, so they are equal. And we know that pentagon has 5 sides. We can draw the graph. So approximately something like this we have. The sides should be equal. We have 5 sides and they are equal. So to find the length of side, we have to write equation, because the expression 11x minus 25 and 9x plus 5 represent the length of two sides of equilateral pentagon. It means that 11x minus 25 must be equal 9x plus 5. So now I will combine the like terms. We will move 9x to the left side and negative 25 to the right side. So we have 11x minus 9x is equal 5 plus 25. 11x minus 9x is 2x is equal 30. So now we will divide both sides by 2. 2 and 2 we can reduce. So we have that x is equal 30 divided by 2 is 15. When we found our unknown x, next we can choose one of these two expressions and we can find the side of our pentagon. Because it doesn't matter which expression you choose, the answer will be the same. So let's put 9x plus 5 will be length of our side. Let's put that L is length of side of pentagon, and this is equal 9x plus 5. This is our L. Every side is the same L. So this is equal 9 times x is 15 plus 5. So this is equal 140. So the length of side of our pentagon is 140. This is my solution. Find the perimeter and area of the shaded figure. We have given here square. Why? Because we have every angle 90 degrees. This square means that we have 90 degrees. What else? Every side is the same length, 8 meters. That's why we have here square. And we know that perimeter is the distance around a figure. So the distance around the figure P perimeter is equal. We have 4 sides and every side has 8 meters. So we have 4 times S. Let me write from the beginning. S is side of our figure. So we have 4 times 8 meters. This is our S. So perimeter is equal 32 meters. Next we have to find area of our square. We know that area is S square. S is a side of square. In this example, S is equal 8 meters. So this is equal 8 meters square. So this is equal 64 meters square. This is my solution. We have given rectangle and we have to find perimeter and area of this figure. So why we have rectangle? Because the sides which are across have the same length. We have 6 feet and opposite side has 6 feet. And we have 3.4 feet. And the angles are 90 degrees. This means that these angles are 90 degrees. So because opposite sides have the same length and the angles are right, so we have rectangle. And we know that perimeter is the distance around a figure. So when we walk around the figure, we see that we have two sides which length is 6 feet and two sides which length is 3.4. So we can write we have 2 times 6 feet and we have 2 times 3.4 feet. So our perimeter is equal 2 times 6 is 12 feet and we have 2 times 3.4 is 6.8 feet. So this is equal 18.8 feet. Now we have to find the area of our rectangle. Area is equal length times width. So we have 6 feet times 3.4 feet. So this is equal 20.4 feet square feet. Area is measured in square units always, and perimeter is measured in units of length. So this is my solution. We have to find perimeter and area of a shaded figure. We have given here triangle, and first we have to find the perimeter. The perimeter is the distance around a figure. Our P is equal. In this example, we are interested on this shaded figure. So we have this part has 3 inches plus next we have 15 inches and we have 12.7 inches. So this is equal 30.7 inches. Next we have to find the area of our shaded figure. This is triangle. To find area of our triangle, first we will find area of our right triangle and we will subtract this smaller area of a smaller right triangle. So let's put that this is our first triangle, this is our second triangle. We need to find area of our second triangle. And like I said, first we will find area of our right triangle. Let's put that area of our triangle is equal. We have to use formula that the area is equal 1/2 times base times height. of our triangle. In this example, our base B, this whole right triangle, has base B is equal 9 inches plus 3 inches. So this is equal 12 inches. What else? The height of our triangle is 9 inches. So we had the area of our triangle is equal 1/2 times 12 inches times 9 inches. So this is equal 1/2 times 12 is 6, 6 times 9 is 54. Of course, we have square inches. So we found area of our right triangle. Now, if we subtract from this triangle the area of this white triangle, we will get this shaded figure, area of this shaded figure. So let's put that our area 2, because we need area of 2, the second triangle is equal A minus area of 1 triangle. So this is equal. We need to find the area of a small triangle. So area of this triangle is equal 1/2 times base times height. The base of this right triangle is 9 inches and the height is 9. So this is equal 40.5 square inches. So now we will come back to our equation. From area of our whole right triangle, we have 54 square inches. We have to subtract area of a small right triangle. So this is 40.5 square inches. So area of our shaded triangle is equal 13.5 square inches. This is my solution. We have to find perimeter and area of a shaded figure. We know that the perimeter is the distance around the figure. We have here triangle and we see that sides of this triangle are the same. So our perimeter is equal, the base is 8 meters and two sides are the same, so we have 2 times 5 meters. So this is equal 8 plus 10, so this is 18 meters. We have our perimeter and now we have to find the area of our triangle. We know formula for area of triangle is 1/2 times base times height. In our example, base is equal 8 meters and height is 3. This is our height of our triangle, 3 meters. So we have that our area is equal 1/2 times 8 meters times 3 meters. So this is equal 1/2 times 8 is 4 times 3 is 12 and meter times meter is square meters. This is my solution. We have given that area is equal 100 square meters and we have to find the side of square. So we have given area of square. We know that the area of square is equal s square, where s is side of square. We have given a. We can rewrite our equation that s square is equal a. So we have that s square is equal, a is 100 square meters. So let's put only 100. When the units we will put at the end. So s square is equal 100. So s is equal plus minus 10. But in this example, we are talking about the side of square. Side of square cannot be negative. So our answer is that side of our square is 10. Of course, because we have here square meters, so the side is 10 meters. This is my solution. We have given that area is 48 square millimeters, and we have given that this is area of triangle, and this triangle has height 8 millimeters. We have to find the base. So let me remind you that the formula for area of triangle is 1/2 times height times base. In this example, we have given that A is equal 48 millimeters, square of millimeters, and we have given that height as 8 millimeters. We have to find B, base. So this is given. So now we can substitute to our formula that A is equal 48. We can put the units. So we have square millimeters. This is equal 1/2. The height is 8 millimeters times 8 times base. So 1/2 times 8 we can reduce, will be 4. So we have 48 millimeters, of course square millimeters, is equal 4 millimeters times B. Let's put this in parentheses. Now we have unknown B, so we will divide both sides by 4 millimeters millimeters. We can reduce 4 and 4 millimeters with square. 48 divided by 4 is 12 millimeters. This is equal our B. So we can rewrite that our base of our triangle is 12 millimeters. This is my solution. We have given radius r and we have to find the circumference and area of a circle. So let's draw first the circle. We know that diameter, this is our diameter, and the radius r. We know that formula for circumference C is equal P times D. In this example, we have given R, and we know that D is equal to R, to radius. Diameter is equal to radius. So our circumference is equal pi times d is equal to r. We know our r is 14.5 centimeter. So this is equal pi times 2 times 14.5 centimeter. So this is equal, we can use calculator. We have pi times 2 times 14.5. This is equal 91.10, and we have to round to the nearest tenth, so it's exactly 91.1. centimeter. Now we have to find the area of our circle, and we know formula for area is pi r square. So we have pi times r is 14.5 centimeter to second power, so this is equal, we have pi times 14.5 square, so this is equal, and we have to round to nearest tenth, so it will be 660.5. Of course, square centimeter. This is my solution. We have given diameter d, and we have to find circumference and area of circle. So let's draw a circle. We know that diameter is 2r. So let me remind you formula for circumference. We have that c is equal pi times d. So this is equal pi times 7 inches. So this is equal, you can use calculator, pi times 7. So we now have to round to the nearest tenth, so will be 22 inches, and area of circle is pi times r square. We have given here diameter, and we know that diameter is equal to r. So our r will be 1/2 of d. So this is equal 1/2 of 7 inches, because d is 7 inches. So this is equal 3.5 inches. So this is equal, we have pi times 3.5 inches to second power. So this is equal, you can use calculator. We have 3.5 square times pi, so this is equal, and we have to round to the nearest tenth, so it will be 38.5, because the number after 4 is 8 is greater than 5, so we have to add 1 to 4. So we have 38.5 square inches. This is my solution. Mark has rectangular garden. The garden is 5 and 1/4 yards long and 2 and 1/4 yards wide. One bag of wood chips covers 10 square feet. How many bags of wood chips does he need? So first, let's draw the graph. We have rectangular, and we know that this rectangle is long 5 and 1/4 and wide 2 and 1/4 yard. course. We have to find how many bags of wood chips does he need. First we have to find the area of our rectangular. So we know that the area of rectangular is width times length. So we will have 2 and 1/4 yard times 5 and 1/4 yard. So this is equal. We can change this to decimal numbers. So this is 2.25 and 5.25 yard times 5.25 yard. So this is equal 2.25 times 5.25. This is equal, it approximately is 11.8 square yards. And now we know that one bag of wood chips cover 10 square feet. We have yards here. So now we have to change our yard to feet. We know that 1 yard is equal 3 feet. So we can rewrite our area is equal 11.8 yard, let's put in parentheses square, is equal 11.8, and instead of yard we can put 3 feet because 1 times yard is yard. So we have times 3 feet square. So this is equal 11.8. 3 to second power is 9. And we have square feet. So this is equal 11.8 times 9. This is equal 106.2 square feet. Now we find our area in square feet. So we have to come back to our problem. We know that one bag of wood chips cover 10 square feet. So now the number of bags will be our area of our rectangular divided by 10 square feet. So we have that area is 106.2 square feet over we have 10 square feet. So square feet we can reduce, and we have that this is equal 10.62. So we have to run this number to whole numbers, so this is approximately equal 11. We need 11 bags of wood. This is my solution. We have to find the side length of a square with the given area. A is 1152 square kilometers. We know that the square has equals sides. We know also that the area of square is square of side, so as square. We have given that area is 1152 square kilometers. This is our S square. So now S is our square root of 1152 kilometers to second power. We only choose positive value because side cannot be negative. So this is equal approximately, you can use calculator, square root of 1152 is 33.9, so we can round, and will be to a nearest 10, so will be 33.9 approximately. And of course kilometers. This is my solution. We have given that the area of rectangle is 48 square centimeters and its perimeter is 32 centimeters. Find the length and width of the rectangle. So let me remind you, rectangle has the same sides which are opposite. So this is our width and this is our length. They are the same. And what else? We know that the area of rectangle is length times width, and the perimeter of rectangle is 2L plus 2W, because the perimeter is the distance around our figure. So we have two sides L and two sides W. And what we have given, that area is 48 and perimeter is 32. So we can substitute A by 48. This is equal LW. And we have that perimeter is 32. This is 2L plus 2W. We have two equations, two unknowns. So let's first copy the first equation. We have 48 equals L times W, and in the second equation we can factorize 2 on the right side. So we have 32 is equal to 2 times L plus W. Now we can divide in the second equation both sides by 2. So we will have 32 divided by 2 is 16. And on the right side, 2 will reduce. Let me do this here. 2 and 2 will reduce, and we have that 16 is equal L plus W. So we can find L or W from this equation and substitute to the first equation. Let's move W to the left side. So we will have that 16 minus W is equal L. We can rewrite this, that L is equal 16 minus W. So now we will substitute L by 16 minus W. So we have 48 is equal 16 minus W times W. So we have to do multiplication on the right side. We have 48 is equal 16W minus W square. So we got quadratic equation. We will move right side to the left side. So we have, now will be positive W square minus 16W plus 48, this is equal 0. We have quadratic equation. We have to find two numbers which multiply by each other give me 48, and when I add them I will have negative 16. It will be negative 12 and negative 4. So we have W minus 12 times W minus 4 is equal 0. So we have that W is equal 12 and W is equal 4. We got two solutions. So now we have to come back to our L. L will be equal 4. W equals 12. We will have that L is equal 16 minus 12, so this is 4. And for W equals 4, we will have L is equal 16 minus 4, so this is equal 12. We got two solutions. When width is 12, of course we have to add centimeters because we have given area in square centimeters and perimeter is 32 centimeters. So the width will be 12 centimeters and then the length is 4 centimeters, and when width is 4 centimeters, the length is 12 centimeters. This is my solution. The area of triangle is 12.5 square inches. Its height is 4 times the length of its base. Find the height and base of a triangle. Let me draw the triangle. This is our base. This is our height. And we know that the height is 4 times the length of base. So it's 4 times b. We can write. And we have given area. And let me remind you, formula for area is 1/2 times base times height. So now we can substitute area by 12.5. We have square inches. 0.5 square inches is equal 1/2 b times h. H is 4b. So we have times 4b. So we can reduce 2 and 4 will be 2. We have 12.5 square inches is equal 2b square. So now I will divide both sides by 2 to find only b. So it will be 2 and 2. So 2 and 2 we can reduce. I will change the sides and we have that b square is equal 12.5 divided by 2 is 6.25 and we have square inches. So our b is equal plus minus 2.5 because square root of 6.25 square inches is 2.5 inches. Because b is base and base cannot be, because its length of base cannot be negative, so we have only b is equal 2.5 inches. We cannot choose negative value for base. So now we need to find the height. We know that height is 4 times the length of base. So h is equal 4 times b. So this is equal 4 times 2.5 inches. So this is equal 10 inches. This is my solution. The width of rectangle is 3.5 feet. Its perimeter is 19 feet. Find the length of the rectangle. Let's draw the graph. We have rectangle. we know that the sides which are opposite, they have the same length. So this is our width and this is our length. What else? We know that the perimeter of rectangle is equal to times L times length plus 2 times width. We have given that the width is equal 3.5 feet. And we have given that perimeter is equal 19 feet. We have to find the length of rectangle. So let's replace our perimeter and our width by the given values. So we have that P is equal 19 feet. This is equal 2 times L, we don't know L, and we have plus 2 times W. W is 3.5 feet. What we can do next? We can do multiplication on the right side, so it will be 19 feet is equal to L plus 2 times 3.5 is 7 feet. Next, I will move 7 feet to the left side, so we have 19 feet minus 7 feet is equal to L. 19 minus 7 is 12, of course, feet. This is equal to L. Next, we will divide both sides by 2 and we have our unknown L. 12 divided by 2 is 6 feet. This is our L. So we can rewrite that length of our rectangle is 6 feet. This is my solution. The frame of window is regular hexagon made from pieces of bamboo. Use the diagram to find how many feet of bamboo are used in the frame. So first, let me remind you that regular hexagon has 6 equal sides. Every side has the same length. And what else? Regular hexagon has the same angles. In this example, we need only the sides. And because we know that the sides are equal, so we have equation that 8x minus 2 should be equals to 3x plus 13. Now we don't care about units. At the end we have to add inches. So we have that 8x minus 2 is equal 3x plus 13. We can move 3x to the left side and negative 2 to the right. So we have 13 plus 2. And 8x minus 3x is 5x is equal 15. To find x, we will divide both sides by 5. So we have that x is equal 3. We have our unknown x. So now we can use one of these two expressions and find the length of our hexagon, because these sides are the same. So, for example, let me use this expression 8x minus 2. So we have that, let's put that this is our length of side is L, is equal 8x minus 2 inches. So this is equal 8 times 3 minus 2. I just substitute x by 3 inches. So this is equal 8 times 3 is 24 minus 2 is 22 inches. We found the length of side of our hexagon. This hexagon has 6 sides. So we need to find how many feet of bamboo are used in the frame. So we need to calculate the perimeter of our hexagon. So perimeter is the distance around a figure. So we have 6 sides. So 6 times L. So this is equal 6 times 22 inches, of course. So this is equal 132 inches. And we need our answer in feet. We know that 1 foot is equal 12 inches. So we have only inches in our solution. So I will divide both sides of our equation by 12 to find only inches. So it will be 12 and 12 we can reduce, and I will change the sides. So we have that in 1 inches, we don't have to write 1 is equal 1 over 12 foot. We have 1 over 12. So now I will substitute inches by 1 over 12 foot. So this is equal 132 we have to copy, and we have times 1 over 12, and we have feet. So this is equal 11 feet, because 132 divided by 12 is 11. So this is my solution. Find the perimeter of quadrilateral KLMN. Find the area of triangle KLM and the area of triangle MNK. What is the area of quadrilateral KLMN? Use the diagram below. So we have given here quadrilateral KLMN. We see that when we fold a sheet of paper along of x-axis, we will see that the point LNN, because has coordinates 0 and 3, 0 and negative 3, are symmetric. Point L and N will cover each other. And when you fold a sheet of paper along of y-axis, points K and M cover each other too. We see that when we fold a sheet of paper along of y-axis, the segment KL and LM will cover each other, and KN and NM which cover each other. And when you fold this sheet of paper along x-axis, again we have that KL will cover KN and LM will cover NM. So we can say that we have here regular quadrilateral. So the sides are equal. So we can write that segment KL is equal to LM and MN is equal to NK. Or you can write Kn, it doesn't matter. So we have regular quadrilateral. So now to find the perimeter, we need to find distance around this quadrilateral. So we need only to find only one segment because they are equal. So to find the distance between 2 points, we have coordinates of these points. We can use point K, L, or L, M, or M, N, or N, K. It doesn't matter which segment we use. The distance will be the same. So let's put that we will find the distance of segment can be KL. We will use formula. Let me remind you, when we have 2 points, this is first coordinate x1, y1 and x2, y2. So we have to find the square root of in first parenthesis we have x2 minus x1 to second power plus y2 minus y1 to second power. So this is equal. We have square root of x2 is 0, 0 we have minus -4, -4 to second power, close parenthesis, plus, and we have y2 is 3 minus 0, 3 minus y1 is 0 to second power. So this is equal. We have square root of 0 minus -4, so negative and negative give me positive, so we have 4 to second power is 16 plus, and we have 3 to second power is 9, so this is equal square root of 25, so this is 5. We have distance of segment KL because these segments are the same. So now to find the perimeter of quadrilateral KLMN, perimeter of quadrilateral KLMN, we need to multiply this distance by 4 because we have 4 sides, 1, 2, 3, 4. So we have 4 times KL segment, so if this is 4 times 5, so this is equal 20 units. Now we have to find the area, first the area of triangle KLM. Because we see that the points K and M are symmetric about y-axis, so the distance from point, let's put that this is point O and has coordinates 0, 0. From K to O is 4 because the first coordinate is -4, so we have to take absolute value of -4, so this is 4 units. And on the other side, from O to M, first coordinate is 4, so is 4, 2. This distance is 4. So we have the base of our triangle KLM. The base of triangle KLM is equal, we can say, to the base of triangle MNK. MNK. So let's put that this is base of triangle MNK and is equal 4 plus 4, so this is 8 units. We have the base, and now to find the area of triangle we need the height. Let's see first for triangle KLM. The height is from point O to L. Because the second coordinates of point L is 3, it means that our height is equal 3 units. And because we see that point L and N is symmetric about x-axis, because we have coordinates 0, -3 and 0, 3. So when we fold this sheet of paper along of x-axis, these points L and N will cover each other. So we have that the height of triangle MNK is absolute value of -3 is 3. So this is our height, the same like OL segment. Now ON is 3, 2. So I use the same letter H. So we can write that height of triangle KLM is equal to height of triangle MNK and is equal 3 units. We have base, we have height. So now to find area of our triangle KLM, because we have the same base and the same height, so we can write that the area of triangle KLM is equal to area of triangle MNK, and this is equal 1/2. Formula for area of triangle is 1/2 times base times height. So this is equal 1/2. B is equal 8 units times height is equal 3 units. So we have 2 and 8 we can reduce. So we have 4 times 3 is 12. And of course, because we have area, so will be square units. You can put in brackets. And now we have to find the area of quadrilateral KLMN, because we found the area KLM triangle and M and O, they are the same. The area of quadrilateral KLMN will be the sum of areas triangle KLM and MNK. So we can write that the area of quadrilateral KLMN is equal area of triangle KLM plus area of triangle MNK. These areas are the same, so we have to put just that this is 2 times area. You can put triangle KLM or MNK, it doesn't matter because they are the same. So let's put KLM. So we have 2 times area KLM is 12 square units. So this is equal 24 square units. This is my solution. Points A and B represent the positions of 2 men in a lake. Point C represents the position of a boy. Find the distance from each man to the boy. The man at point A swims forward the boy in a straight line at a rate of 1 km per hour. The man at point B swims to the boy at a rate of 1.2 km per hour. Which man reaches the boy first? So first, we need to find the distance from each man to the boy. Let me remind you formula for the distance. When we have 2 points P, x1, y1 and R, x2, y2 coordinates, the distance PR is equal square root of difference of x2 minus x1 to second power plus y2 minus y1 to second power. So in our example, first we have to find the distance between points B and C and A and C, of course. So let's put first the distance AC is equal. This is our x2, y2, and this is our x1, y1, x1, y1. So we have square root of x2 is 8 minus x1 is 2 to second power, of course, and we have plus 6 minus 2 to second power. So this is equal square root of 8 minus 2 is 6 to second power is 36 plus 6 minus 2 is 4, 4 to second power is 16. So this is equal square root of 52. And next we have to find the distance of man B from point C. So BC is equal square root of, and we have x2 minus x1 is 8 minus 1 to second power plus y2 minus y1, so is 6 minus 8 to second power. So this is equal square root of 8 minus 1 is 7 minus the to second power is 49 plus we have 6 minus 8 is negative 2 to second power is 4. So this is equal square root of 53. We found distance from man B and A to boy C. Next, we know that man at point A swims forward the boy in the straight line at a rate of 1 km per hour. And the man at point B swims to the boy at a rate of 1.2 km per hour. Which man reaches the boy first? So we need to find the time. We know that the speed, the velocity, is equal distance over time. So we have given distance, we have given velocity, we need to find the time. So first we have to find from this formula time. We can put velocity over 1, so now we can cross multiply. We have v times time is equal 1 times distance, so this is distance. So next, to find time, we will divide both sides over v. So v and v we can reduce, and we have that time is distance over velocity. First, we will calculate the time which need man A, from point A. The distance is man A to point C, the boy, is square root of 52. Of course, we have given this diagram in kilometers here. And here we have distance in kilometers. So now we have square root of 52. We have to add units, this is kilometers, over velocity is for man at point A is 1 kilometer per hour. So it's over 1 kilometer per hour. So kilometer and kilometer will reduce. Square root of 52 divided by 1 is square root of 52. We have 1 over hour. So we can flip this fraction. So it will be square root of 52 hours. So now we know that square root of 52 is approximately 7.2 hours. Now we have to do the same for the man at point B. The time will be the distance the man at point B to the boy is square root of 53. The same, we have this diagram in kilometers. And the velocity is, the speed is 1.2 kilometers per hour. So we have 1.2 kilometers per hour. So kilometers and kilometers we can reduce. So we can use calculator. Square root of 53 divided by 1.2. This is equal approximately 6.1. We can write. Of course, hours. So we see that the man at point B will swim only 6 hours, 0.1 of hours, and the man at point A will swim more than 7 hours. So first will be the man at point B. The answer is that the man at point B will be first. Mary is designing a cover for circular swimming pool. The diameter of the pool is 24 feet. The material for the cover costs $3 per square yard. How much will it cost Mary to make the pool cover? Round to the nearest tenth. So first let me draw our swimming pool. That's a circle. We have given diameter. D is equal to R. R is the radius. So we have given that D is equal 24 feet. The cost for the covered is $3 per square yard. We have to find how much will it cost. So first we have to find the area of our swimming pool. Because this is the circle, we know that the area of circle is pi r square. In our example, we have given D. D is equal 24 feet. So we know that R is equal 1/2 of D. So this is equal 1/2 times 24 feet. We can reduce 2 and 24 will be 12. So we have that r is equal 12 feet. We found r, so we can calculate the area of our swimming pool. Area is equal pi times 12 feet to second power. So this is equal, you can use calculator. We have 12 square times pi. So this is equal, approximately, we need to round to the nearest 10th. So after 10 we have 8, so we have to add 1, 2, 3. So it will be 452.4. 452.4 square feet. We have area of our swimming pool. Now we have to find the cost of our cover. What we have given? We have given that the cover costs $3 per square yard. So first we need to change our feet to yards. Let me remind you that 1 yard is 3 feet. Because we have feet here, so I will divide both sides by 3. So we have that 1/3 yard is equal 1 foot. So now we have to come back to our area and substitute foot by yard. So this is equal 452.4, and in parentheses we will put 1/3 yard, because we have feet to second power, so we have to put to second power. So this is equal 1/3 to second power will be 1/9, so will be 452.4 over 9 square yards. So this is equal, can use calculator, 452.4 divided by 9. So again we need to round to the nearest 10th. So after 2 we have 6, so we have to add 1 to 2. So it will be 50.3 square yards. To find the cost of our material for the cover, we have to multiply area of our swimming pool. Of course we have here square, times $3. So this is equal, we have dollars per square yard. So I should put $3 per square yard. So square yard we can reduce, and we have, of course, dollars. This is the cost of cover for swimming pool. This is my solution. The perimeter of the triangle shown is 120 yard. Find its area in square yard. So first we have to find the height and the base of our triangle. We have given that the base is x, the height is x plus 10 yards, and this part is x plus 20 yards. So we can use this information, and we have given perimeter is 120 yards to find our unknown x. Because the perimeter is the distance around our figure, so we have that P is equal x plus, of course, yard. We have to add at the end, plus, next we have x plus 20 yards, and we have plus x plus 10 yards. Now we can substitute perimeter by 120. So we have 1, 2, 3x, and we have 20 plus 10 is 30. Next, I will move 30 to the left side, so we will have 120 minus 30. This is equal 3x. So 120 minus 30 is 90. This is equal 3x. We need to find x. So now I will divide both sides by 3 because we have here multiplication. So 3 and 3 we can reduce. And we have that x is equal 90 divided by 3 is 30. Next, when we have unknown x, we can calculate the base and the height. When we have base and height, we can find the area of our triangle, because we know that the area of triangle is equal 1/2 times base times height. So our base is equal x yard. So x is 30, so we have 30 yards. And our height is equal, this is our base, this is our height, is equal x plus 10 yards. So this is equal 30 plus 10 yards. So this is equal 40 yards. We have base, we have height. So now we can come back to our formula for area of triangle. Area of triangle is equal 1/2 times base, so times 30 yards, times height is 40 yards. So this is equal, we can reduce 2 with 40 will be 20, and 30 times 20 is 600. Yard times yard will be square yards. This is my solution.